That 1, 2.
Yeah.
Hello, everyone. My name is Svetlana Krasliolu. I'm a technical writer at Pachyderm. Thank you for coming today, despite all the concerns with all kind of things. And happy International Women's Day to the ladies in the room. How many of you have done some data science, machine learning? Okay, cool. Thank you. And how many of you are familiar with Docker and Kubernetes? Cool. So today we're going to talk about reproducibility, what it means, and why should we care. Okay, so these days we see an increase in the use of AIs in every industry. We see AIs being used in healthcare, HR, automotive, many other areas. Enterprise growth has been skyrocketing in the last few years. There are a bunch of AI courses out there. Private universities and public universities are offering all kind of programs for data science and AI courses together with a bunch of boot camps. And every day more and more people are enrolling in all kind of AI and machine learning programs to update a data science degree. And we all seem to be approaching the future powered by intelligent machines we all have been dreaming about, and these machines are going to do everything for us while we're going to just enjoy our time, or will we? So. Yeah, And in the last few years, a number of AI startups skyrocketed as well. So let's take a step back and look at the history of AI efforts in the 20th century. Although for some of us AI is a new thing, AI as a field of study has been around for a very long time actually, and the Dartmouth Summit research program project in 1956 was considered the founding event, after which there was a series of AI successes and failures, including the creation of checkers program that eventually beat its own creator, and the unification algorithm, and many, many other things. We all know that success of any industry really depends on funding, and then the initial results were not delivered. Investors kind of lost their interest. But that gave time for data scientists to devise new methods that were much more mathematical. Statistics, probability theory became widely deployed. And what else happened during that time is that hardware became much faster and cheaper. Some AI algorithms are very computationally intensive, such as image processing. So this all brought us to 2010s, when speech and image recognition technologies thrived, which created a new wave of AI excitement. Sorry, oops. So AI machines became much smarter and much stronger. And in 2017, we had another breakthrough with the AlphaGo creating an algorithm that was able to beat the world Go champion. And some people even thought that that event means that it's the time when the general purpose AI can be invented as well. Have you guys played Go? So if you guys are not familiar with Go, Go is much, much harder than chess. With chess, chess only has 400 possibilities, while Go has more than 100,000 of possibilities. So that was a big step. So obviously, data science is again the hottest topic, with the number of open positions for data scientists. Thousands of people are working to make our lives better, including probably you. But can these algorithms also be wrong? Over the last decade, we've seen a few whooping AI failures that all started as promising projects. So we probably all remember IBM Watson. That was an ambitious Microsoft project in 2014. Watson was supposed to revolutionize healthcare. In a few public demonstrations, Watson was given a list of symptoms and came up with a list of possible diagnoses and came up with a list of diagnoses with a remarkable accuracy. Unfortunately, the results that Watson was providing when tested in real life were very far from being accurate. Its oncology diagnoses were completely off, and the ultimate reason of this was because Watson's data scientists didn't have access to real data. They had to come up with a synthetic data set, which is an extremely difficult task that can easily go wrong. Like in a math problem, if the first step is wrong, all the rest are automatically wrong. In the end, from the glorious promise of becoming a super intelligent AI doctor, Watson has been reduced to a humble role of an AI assistant. Another example of bias another example of an AI failure is image recognition. One of the experimental models in University of Washington was designed to browse through images and identify whether the image had a husky or a wolf pictured on it. While the model was seemingly predicting the results with 90% accuracy, over time, data scientists understood that the model was identifying some of the images incorrectly. And the model was actually not identifying huskies or wolves, but the snow on the pictures. Because most of the huskies were pictured on the grass, and most of the wolves were pictured on snow. This example shows that even if you think that your algorithm is working correctly, it might be doing a completely different thing from what it was designed to do. And of course, bias is a big problem of any data sets. So for example, in some languages, including Turkish language, the word o can mean both she and he, depending on the context. And then the context is ambiguous. The system chooses to reflect what is already a gender stereotype in the society. For example, Google translated the phrase, he, she is a scientist into its masculine form, and the phrase, he, she is a secretary into its feminine form. This is how bias can sneak into a data set that is not overall bad, and such bias cannot be predicted. So this is just a few examples, but they all have a common pattern. The data set that the data scientists used was either incomplete, artificially created, or biased. Today, when AI is becoming instrumental in the decision-making process across multiple industries, we need to make sure that we have established standards to control the quality of the AI systems. Every day we hear that AI is hurting people, breaking their lives. If one day your rating is off by a few numbers in that system, that might have devastating consequences. It would be extremely difficult to recover from something like that, and no one is protected from this. Another side of the problem is that a large number of studies cannot be reproduced. The Nature magazine conducted a study which revealed that over 70% of scientists cannot reproduce results of other scientists, and even their own. They can't reproduce their own experiments. And most of the scientists agree that the main reason is that the data is cherry-picked to support a hypothesis. We see similar problems and tendencies in data science for the same reasons. And I think this is very scary. To help improve transparency and reliability of data science experiments, the following seems to be essential. The quality of analyzed data must be improved. While trying to improve a hypothesis, it might be tempting to cherry-pick data. Organizations must have a robust process that verifies that the data that is being used to train an algorithm is complete, unbiased, and diverse. The sample size must be large as well. The number of published AI papers grew from just a few of them in the 90s to more than 15,000 in 2015, and this number keeps growing. Because of the hype, it is hard to keep up with this amount of papers and understand which of them are truly scientifically important and which are not. The number of trials in many of them is shockingly small. The tooling must ensure that there is an audit trail available to other scientists to recreate the same results. Well, of course, some of the AI implementations are not ideal, but we cannot really live without AI. On a large scale, AI significantly improved the quality of our lives. The current state of AI infrastructure is now mature enough and needs production-ready solutions and processes to reach the level of stability and accuracy we need. So, what would help data scientists to better track their experiments and correct them as needed on a regular basis? What kind of system can help to ensure that you can always go back and fix a biased algorithm? And what should people who consume the results of the AI work demand from the AI platform providers? If you look at the software development, there is a life cycle, right? So we have all the stages that are pictured on this slide. Software lifecycle includes multiple interactions of planning, developing, testing, releasing, and maintaining the software. Tools like a version control system and continuous delivery became natural for any software development team. Data scientists deserve to have the same level of reliability. Data scientists need a system that can track versions of data sets used to train their algorithms. A version control system, similar maybe to Git, that tracks dataset changes and the provenance of their results. Unfortunately, Git cannot really solve this problem because Git has a file size limitation. And AI datasets are massive, sometimes with gigabits and petabytes of binary data. So what does a reasonable data science solution look like? Today we hear this new term more and more often, ML ops or AI ops. The goal of ML ops is to provide a reliable infrastructure for reproducible and verifiable data science. And at Pachyderm, we have built such a platform. If we think about software development as a pipeline, this is probably how it looks like. Developers write code, they store it in a version control system, they run their tests, and then they deploy them to production, and then they do the same thing all over again. And if we think about data science pipeline, this is how it may look like. So the data scientist would acquire data, clean it, train it, test it, and then deploy it to production. So this is high level, but more or less this is what it is. So what is Pachyderm in a nutshell? It is those three things on the slide. It is data versioning, data pipeline, and data lineage. Pachyderm operates with concepts like repositories, branches, commits that are familiar to everyone who uses Git or GitHub or a Git-based system. Pachyderm enables you to Pachyderm enables you to manage and version control your data in much the same way Git does for code. In Pachyderm, you can version control petabytes of data with many of the same commits that are immutable snapshots of your data. And then you can also see what happened to that data set over time. On this slide, we have a repository that is called images, and it has a branch, master. And these are all the commits that were submitted into that repository. You can access those commits at any time by that hash number, very similar to Git. Data pipelines. So data pipelines is another Pachyderm concept. Not only you need to version your data, but you also need to transform and process your data. Building multi-level transformations against your data is fundamentally important. In Pachyderm, we make pipelines completely Kubernetes native. Every pipeline is a Kubernetes pod. A pipeline can run your containerized code against the data that you put into your Pachyderm repository. It can use any languages and libraries you want because it's a container. It does not matter what type of data science you are doing. It doesn't matter in which industry you work in, whether you are doing bioinformatics or genomics, or you're using some special library, whether you write in Python or R or Go, it does not matter, because all it goes into a container. Your pipeline puts the results into an output repository. So you have not only you have your input data version, you also have your output data version as well. Every time you put new data into a Pachyderm repository, Pachyderm triggers a job that runs that pipeline against that new data. So you can see here on the slide, we have a DAG for, actually I think it's a hyperparameter tuning example, where we have the parameters repository, we have our model, we have the split step, we have the test step, and in the end we have this, we select the best model out of them. Now that we understand that we can have multiple pipelines chained together, and we can have multiple repositories, this brings us to our last concept, which is data lineage. Have you heard this term before? Data provenance or data lineage? Yeah. So data lineage helps you to understand where data originates in and what happens to it over time and how you got the present result. Data lineage in Pachyderm traces your data across multiple repositories. You have many versions of your data, but you also have many versions of your code. All these pieces intertwine in a very complicated combinations of different versions of data and code being used in transformations. Data lineage enables you to look at results of your data pipeline and then see every version of data and code that led you to that result. And not only that, it shows you how every version of data relates to every version of code. And this is crucial for reproducible data science. Data lineage is a property of your data. It's important not only to version your data, but also to understand its origin, and this is what data lineage gives you. So as you can see here, every commit in Pachyderm has this little field called provenance, and you can see every single pipeline that contributed into that result. So you can track how you got there. All right, and so the last thing that I want to show you before we jump into a demo is the overall Pachyderm architecture and how it relates to the broader ecosystem. Pachyderm runs on top of Kubernetes, meaning that it can be used in all major cloud platforms like AWS, JKE, Azure, as well as on premises. And it provides all the benefits of a containerized application, which includes portability, self-healing, resource isolations, and many others. And we do work with major data science tools, such as Jupyter Hub and Kubeflow. And we really closely work with folks from Seldon and Comet ML. And the very last thing is that for those who are not as familiar with Kubernetes, but who still wants to keep track of data version and provenance, we have recently launched a hosted version of Pachyderm, which is called PackHub. So make sure to check it out. You can run your experiments online as well. And for today's demo, I've chosen a very simple example of data detection, edge detection with the OpenCV library. So we have, if you are interested to try out this example, it can be found on GitHub in our repository under examples. Basically, we have two pipelines here, which is edges pipeline that performs the edge detection, and montage pipeline that uses ImageMagick library to create a montage of the images that we have. And we have, and we use a very simple script that we wrote and image magic montage command. And this is what it's going to do. So each detection basically going to take this picture and turn it into this picture. So this is how the pipeline looks like in Pachyderm. As you can see, we have a repository called images that we've seen before on other slides. We have a transformation section where we specify our Docker image, which is in this case Pachyderm OpenCV. And we have a command that we execute, and it's Python 3 that executes the script that we wrote. This is our very simple script that basically creates the, does the edge detection and then goes and performs for every single file that it finds in the repository. Yeah, and this is our montage pipeline that basically, so it uses a bit of a different technique from the other one. Here we combine inputs from two repositories. One is the images repository, and one the results of the edges pipeline. And this is our transformation step that basically takes the montage command from image magic Docker image and performs and creates the image with the following parameters. All right, let's do the live demo. So I already have a Pachyderm cluster running on my laptop. So if you are familiar with Kubernetes, you can do kubectl, get pods.
Make it slightly bigger.
Oh, right, sorry. So you can see we have 3 pods, and they are all Pachyderm cluster pods, which is a packd is a server, and dash is the UI, and etcd is the etcd value store. Okay. So first thing we're going to do, we're going to create a repository that we're going to call images. And if we do Pasadena list, I'm sorry. So this is our repository that we created. Next thing we're going to do, we're going to put an image into that repository, which is stored in here, and we're going to call it Liberty. All right, I'm going to do clear really quick. And now we can see our repo right here. We can see that we added 57 kilobytes into that repo. And we can also check what the commits. So as soon as we add an image, there is a commit added for it as well. And you can also and you can also see the file itself in the repository. And if we try to open it right here, I'm sorry, it opened on my, let's do it once again. Yeah, just open it right here. All right, and next step will be, the next step we're gonna create, in our next step we're gonna create the pipeline edges from a JSON file by using this command. It's a pack control create pipeline -f and the address and the path to the JSON file. All right, and we can run pack control list pipeline. We can see that our edges pipeline is now starting. And we can also check the jobs. Okay, for some reason the job is not there yet. Interesting. For some reason our pipeline. Okay, let's see. Guess it's gonna take a little bit, some time to start the, to run the job. Okay, and if we go into our UI, we can see that we have the images repository and the images pipeline right here, and the output repository that was automatically created to output our results in here. All right. Okay, let's. Yeah, for some reason it's not. Okay, so now we have the job right here. Okay, and it's right here right now. So we have 22 kilobytes added in there. Okay, now we're gonna add a few more. We're gonna add a few more images in here. We're gonna add 80 PNG, and we're gonna add kitten in there. Okay, and if we do pack control list commit images at master, we're gonna see all those images being added. And let's check the job as well. So yeah, it ran all the jobs for that pipeline. Okay, and let's create our montage pipeline. All right. Okay, the job did not keep. Oh no. All right. Okay, the pipeline, it ran the montage pipeline, and the job succeeded, and the pipeline succeeded. Yeah. And we can get this image. We can get our montage PNG. Okay, so it opened on my screen. And this is what it looks like. So, yeah, this is the UI. For some reason, I don't know why it's not working right now, but let's check once again. Yeah, so it added the montage to the tag and shows all the recent jobs and the repository. And we have 3 data files in here that you can see they were added, and the montage is here as well. Yeah, so this is pretty much it. So if you want to try this example, it's our actually beginner's tutorial for Pachyderm. Join our Slack channel, check out PackHub. And let me know if you have any other questions.
So first question is, I guess your presentation is going to be out on the site, right?
Yeah.
Okay, good. So one question I had is, so when you generate the hash and you have a huge amount of data, that will just take a long time, right?
Probably it will
Okay.
take some time. Yeah.
So if you have 100, 500 gigabytes or whatever, you know, if you're going to use this, you have to set up the proper infrastructure for doing
So
that.
you can, in your pipeline, you can set up parallelism for your, you know, you can have multiple Kubernetes workers that would spread the workload. Basically, we have a concept of datums. Each piece of your data, so if you notice in the pipeline, there is a field called glob that lets you break down your data into chunks, so it will process chunk by chunk. There's a
It'll
way
generate just the one hash.
Yeah, yes.
So any change you do, similarly, you know, you'll have to regenerate that hash.
I think so, yeah.
Okay.
So again, you can fine-tune it with the globe pattern that if you have, for example, you have multiple directories and multiple files in those directories, you can specify that by the globe, with the globe pattern, that if you make one tiny change in one file in there, it would only process that datum that that file represents. That on the small.
Add a file to, you know, some in a process, you mean, or you know, some sort of increment. How do you tell, adding a file like this and then changing instead of generating a hash off the entire file?
Yeah, I'm not sure I completely understand the question.
You always have to generate the hash
Yeah.
off the entire file.
Not of the entire data sets. That's what I'm saying. You can break it down to smaller units of computation, and it will still generate the hash, but of that, just of that change, not of the whole data set.
Okay, so it takes a hash of the original and a hash of the change.
Yeah,
And then it generates a new hash.
yeah.
I have a question. How well integrated are you to AWS or some other cloud provider? Like if I want to store my data on S3, or if I want, how would I like fire up EC2 instances to feed it? Like I do have 500 gigabytes I process a day. So how would I use this for this?
You can run it on EKS. We have examples for that. You can store everything in your S3 buckets if you want to. It's pretty seamless integration with all three major cloud providers, AKS, EKS, and JKE. Yeah. Yeah, you can use Minio as a S3 client to Minio. I think S3 CMD and
so any S3 compliant target can be used.
Yeah.
It's probably all up on the site, but what's the infrastructure that you have to have in place? Is it just one binary? I assume not.
Infrastructure in...
Yeah, I mean, so if I want to go and deploy this and use this and so forth, is there anything I need besides whatever you package up?
Like how many nodes, Kubernetes nodes? Or
Yeah, any kind of config, or is it just, you know, push button?
So when you deploy Pachyderm using our pack control client, it generates a Kubernetes manifest that you can deploy anywhere you want by using kubectl apply, basically.
will this run on a single node Kubernetes cluster?
Um,
Like Minikube?
yeah, you can run. So I'm running right now on Minikube, basically, with the minimum.
You have guidelines for,
Yeah, we have that in our documentation, of course. Yeah.
How does this compare to other, like there are many solutions like this? Like yesterday we were hearing about Spark and Delta Lake, which is a sounds very similar to this. Like, can you provide like a compare and contrast of this versus other data pipeline solutions?
I'm not familiar with the one you mentioned. I know that like we can work with tools like Kubeflow, for example, or Airflow or Jupyter Hub, and none of them provides data versioning. They do provide like pipeline stuff, pipelines infrastructure, but not really data set versioning.
Any other questions?
Yeah, so that's kind of a good sort of line of questioning. So again, it almost comes back to the hash, and that is, you know, the thing that you guys really provide is that guaranteed tracking of the state of the data and being able to move it forward in a, you know, sort of managed fashion.
Yeah.
There's no other similar product on the market.
I am not aware of
Me neither.
of such a product. There might be. I heard of other tools. I cannot comment of how much they mimic our offering, to be honest. Yeah. So.
Cool.
All right. Well, thank you very much.
Thank you. Thank you.
So we have another talk in here in an hour, I believe. I actually had it pulled up on my schedule, and then I shut my phone down because I was foolish. I can't remember what it is. Let me look it up. But yeah, you guys can come right back in about, at I believe 1:30. That's our next talk in this track.
So I do have some swag.
There's swag.
It seems it worked. I checked it before.
Okay.
I'll sit over there, which is a little more central.
So thanks to be here for this talk. I'm very happy. Well, you fought the fear of the coronavirus. I'm Nicolas Frankel. I come from France. So a long way, so it's a bit strange to find only 4 people here, but really, again, I'm very happy. Do you understand my accent so far? No, I know that French people have shitty accent. I try a lot to downturn it, but the thing is that when I'm tired, it gets back, and so good. I've been doing a lot of development, well, like nearly 20 years in different positions, as a Java developer, architect, whatever. Mostly as a consultant, so working for different customers. And 1.5 years ago, I had enough of that, because if you are doing consultant work, you go to customers, there are different contexts, but in general, it's always the same problems. Those are people's problem, organizational problem, not technical problem. And then you have to fight your way through all that, and I didn't want that anymore. So I decided, I will be a developer advocate, so I will go to people and make talks, and if you don't listen to my advices, then that's fine. I work for a company called Hazelcost. Who knows about Hazelcost? 2 people, 3 people. If I wait a bit more, perhaps I will get, no, that's fine. So our first product is called IMDG, in-memory data grid, and basically you can think about it like a distributed data structure. So it's the same SPI as you would expect from a normal, for example, normal map, but it's distributed. It's so simple that sometimes you make mistakes because it's very easy to use, but then it's distributed. And the other product that we have is Hazelcost Jet, and I will talk about it in more details a bit further down the talk. So this is the schedule. First, why do we do streaming? So I have a lot of slides about the history of why do we do streaming, the approaches, a bit about Hazelcost Jet, and then about open data, and about specification of the open data called GTFS. And I hope the demo will work, because last time it didn't, and Q&A. Everything that I will show you here is either open source or open data, so you can take everything. In the last slide, there is a link, and you can download the demo and do it yourself. A long time ago, the data was stored in SQL databases. That everybody was happy, but actually, it was not that great. Because even if everything was stored in SQL databases, there were certain kind of use cases that was not that good regarding SQL databases. And mostly those were 2 kinds, analytics, and my general use case is in France. You know, we have a big supermarket. Supermarkets have a lot of power. They are very strong in the economy. They are killing all the other components in the value chain. And basically, everything is sales-driven. And in general, the director or the head of the department, they want the sales number hourly. So that they can say, okay, we didn't sell enough last hour. Now, the next hour, we will make discounts so we can sell more fishes or whatever. And the other use case is reporting. And in general, you've got your monthly or your yearly bank accounts, and you have dedicated databases for that. The problem with SQL is, that's the trade-off. You've got the benefits of transactions. You've got the benefits of deduplication. In order to achieve that, you've got constraints and joins and normal forms, so that actually it's not that great if you want to just read data very fast. You have been taught in university that you should always normalize data, that duplicate data is bad. And we have been working like that for ages until NoSQL came. But for reads, we don't care that much. And also, the correctness is not that important. If I miss, well, on your back statement, it might be a bit of a problem. But for analytics, if I'm off by 0.5%, by 1%, that won't really change my decision in the end. And so there is a need for extract, transform the data, and load it somewhere else. Because the same database cannot cope with that. So we need to take the data, transform it, and put it in another data store. And it's called batch. And we have been doing that for ages. Who never have seen any batch? Yeah. Who here is a developer, by the way? Okay, what are you? You're not sure, or half developer, half ops?
Yeah, mostly system.
Okay. Okay. If something is not clear, just ask me, because I'm very skewed toward development. Though I'm very interested in ops, I'm very skewed. So I assume that everybody either developed batches or operated batches. I mean, it's ubiquitous. Batches have two properties. They have a period of time they are intended to run in, and they run in a specific amount of time. And then comes the problem that you probably also have seen. It takes more time at some point to run the batch than the interval. At the beginning, everything is fine. You don't care that much about performance. They run. And at some point, data grows and grows and increases, and it takes too much time. Not that good. Also, the problem with batches is that they tend to load everything into memory. Again, if the data grows too much and you don't have enough memory, it doesn't work that good. Finally, I guess you also see that happen. If a batch fails during the execution, what do you do? To handle the fact that the data can grow, like 15 years ago, started the big data movement. So the big data movement is just as simple as saying, well, just as simple, but it's very complex in the end. But the abstraction is very simple. Just say, oh, let's distribute the batch on different nodes. Like in general, the usual traditional SQL database, they are not distributed. They mostly run on one node. And if you have good admins, then you have like one master node and slaves. If you have like failure, then failover occurs, then it elects a new leader. But the idea to run like, to do horizontal scaling was basically like very old, but very hard to achieve. And this big data movement and all its technology is exactly that. Let's distribute everything over several machines so that we can scale horizontally, and we are just limited not by the physical world, but by the money we have, because we cannot buy that many nodes. And I also mentioned the schema on read versus the schema on write. So NoSQL say, oh, let's remove all the constraints, all the joins, let's like duplicate data. If they need be, we don't care that much. Regarding the fact that it can fail midway, big data says, okay, every step along the way, we will store the stuff in a persistent file system. Or what you can do if you don't do big data, you can try to handle the data in chunks. And then you keep the cursor, say, oh, I failed during this last execution, the cursor was in this, so I need to redo from this point. But meanwhile, new data might have come in, and then it's another issue. And then comes event-driven programming. The old stuff that, again, you were taught at school regarding interacting with user interfaces. People decided, that's a cool idea. Why cannot we treat data like that? Like instead of handling clicks, then every time something happens, an event, then we have an observer that listens to that event being triggered, and we can react on that. And we can store all those events and replay them or aggregate them or do whatever we want with them. And if you think about that, the fact that events happen in order, in an immutable log, it's how a database themselves are built internally. Actually, I don't know, you might have heard about something called Debezium that reads this log to send events. So the solution is simple. Again, from an abstraction point of view, you make everything event-based. The good thing is you don't need now to keep everything in memory. Every time you've got new data, then that's a new event. This is very memory-friendly. This is much easier to process one event than a whole bunch of data. And on the other side, you've got pull instead of push. So you just need to register, and then you are kept informed about the new events, and then you can process the data. This is close to real time, actually. And finally, now you can handle infinite datasets. Because in general, data is infinite. It's only our mind that tries to make it finite. Like, I was telling you about your bank account, but you can always add more operation. Of course, in 1 month it will be finite, but otherwise, until something bad happens to you, or you close your bank account, then you will always keep appending stuff. And streaming is just this way of looking at things. Streaming is a way at saying everything is an infinite stream of data. And then you can apply everything that you did in your batch to that stream. And that unlocks a lot of features. I mentioned the decision-making process regarding analytics, and the issue with that is that you need to wait until the end of the hour. So you cannot react before. So you need to wait 60 minutes before you understand that the numbers that you were given tells you, hey, you should do a discount. But if you already think that, after 40 minutes, there is a 95% chances that actually you should offer a discount on fishes, that's crazy to wait 20 more minutes. So the fact that you stream gives you perhaps less correct data, but good enough so that you can make your decision faster. What you can do also, and now it's going like super hype, you can take this stream of data and instead of doing like old batch process, you can apply some machine learning stuff on it. And for example, a video is just a stream of images. And finally, if you have been old enough in the development world, you might remember something called complex event processing. That's like the machine learning of old, that we were trying to define the rules by ourselves and not have some algorithm determine the rules for us. So if you are still having this complex event processing dreams, then you can do it now. Now, the events might be a stream, but in general, we still want to keep them somewhere on the disk. Right now, the leader is definitely Kafka. Who knows about Apache Kafka? Okay. I've heard multiple times the Apache Pulsar. That seems to be a strong competitor. I have no experience in Pulsar, so I cannot say whether it's better or not. But if you are interested, you should keep an eye on it. So Kafka is distributed. It's persistent. And it's like the old queues from old. The only difference is that you keep the messages there. And then you have consumers that can read the messages. And also, the huge difference is that the consumer itself keeps the offset of the last read-record. So you can decide to read from an earlier offset or a later or whatever. The good thing is you can have multiple parallel consumers, each having different speeds, and one will consume the events faster, and so advance the offset faster, and the other might be slow. That's not a problem. Everything is possible. That's good with persistence. The downside of persistence is that you need to write on disk, and whether you like it or not, writing on disk is much, much slower than having everything in memory. And for example, about my examples before, about the analytics, I don't care that much about the aggregation of the sales in the last hour afterwards. What I want is I want the result as soon as possible and then discard it afterwards. So in that case, in-memory streaming makes a lot of sense. And you've got a lot of them. Flink, you can have like cloud-based one. You have Jet, of course. You have Beam. That is an abstraction over several real streaming, in-memory streaming engines. And it's interesting, of course, since it was an abstraction that was like designed afterwards, then it's not a really good abstraction, but it's still an idea to say, okay, we will hide the streaming engine behind an abstraction, and then you can like replace it if you are not happy about it. Not sure it will be working, but it's interesting. And Jet is an Apache Beam implementation, by the way. Hazelcast Jets. So again, it's open source. You have got a single jar. That's one big benefit. You can use it embedded in your Java application, or you can use it in a client-server mode. And we have an API that is very similar, whether you do streaming or batching. So you can start to do batching, and then after you get more familiar with the model, how it works, then you can like go to streaming in one line of code. So yes, we have like something that is not open source because I need to be paid to get here, but that's understandable. Every streaming engine needs to have sources and sinks, and Jet is no different. So if you want to compare by yourself, so I'm not trying to sell you Jet, but I hope you will make some comparison by yourself. You need to check what is available out of the box for sources, for sinks. In general, all those operations here are mostly the same. But the real important point is how many out-of-the-box sources and sinks are available, and how easy it is to create a new one by yourself, because of course you will have specific needs that is not covered by the ones here. Jet has two concepts, the concept of a pipeline and the concept of a job. So a pipeline is basically defining the source, the transformation you will make in the pipeline, and the sink. And once you've got the pipeline that is defined, then you can send it to the streaming engine and it will become a job. And then the streaming engine will execute the pipeline, it will execute the code. Very important, it will also create the directed acyclic graph. Now I must think, because we always call it the DAG, but DAG doesn't mean anything. The directed acyclic graph, and trying to distribute the load over all the nodes when possible. Of course, you want to parallelize everything as much as possible. Some operations are not parallelizable, so you can say, oh, this one, no, you cannot distribute it, you must keep it on one node. Who here doesn't understand that code? It's fine, I can explain it. This is Java code. Okay? So this is what we did a long time ago to, well, count the words. You have a string, you create your hash map, and then you say, okay, I will split by space, I will count the words, and if the word doesn't belong to the hash map yet, I will put 1. If it already belongs to it, I will increment the counts. The problem with that piece of code is you are focused on the how. And in general, today, we are more focused on the what. Because we want our libraries, we want our abstractions to do that and to optimize it. We are very bad at optimization in general. I mean, I'm very bad at optimization. So it's better to have an API that describes the what, and the implementation does it in a certain way. This is the same, but using the new Java, well, new, a couple of years ago, Java 8 streaming API. This is exactly the same, but at least everything can be nicely optimized. And if you do Java, you know that by here, changing stream by parallel stream will distribute the load over all the cores. So at Hazel cost, whether INDG or JET, we can create a cluster very easily. You start your Hazel costs instance, and then it will multicast, try to find its siblings. Of course, you shouldn't do that in production, because you want everybody to know about where it belongs, and it's not very secure. But in development, it's very easy. You just start Hazel cost, it multicast, it creates a cluster, everything is fine. And then you can distribute the load all over. And I mean, it's distributed system, so basically, if you want to store like something in a hash map, it will hash the key and check which nodes the key should belongs to. And after some point, in general, you will have failure, or you will have more nodes because you want to scale. It will rebalance everything. Everything should be done for you. You might notice that this is JET API. This is very, very similar to what we did with Java 8. This is very functional. You are focused on the what, not on the how. So here you will say, hey, I will read from this hash map of book lines, and then for every line, I will split the line into words, and the words now are the elements, and if a word is empty, then I remove it, then I group by word, then I count by word, and I put it in IMDG again. So very, very similar. This is how you can think about it. Data is distributed, so it will be read from multiple nodes, and in each node you might have multiple threads. You map, you filter, you aggregate, you combine, and then it gets back here. Again, here, it's very easy because this is an algorithm that can be distributed. Again, some algorithm cannot be distributed. You must be aware of that, and then you must say, oh, this, for example, this operation, it should not be parallelized. And now comes open data. because the talk was called Streaming and Open Data. So open data, I believe, is very important because we focus for a long time on the software itself, on the process itself of the data, but data for a long, long time was very private. And even now, it's very hard to get access to some of it. But this has started to become more and more ingrained in people. And actually, I don't know about the US, because I come from Europe, but in France, the French government has an initiative on open data, the Swiss government has an initiative on open data, the European Union has an initiative on open data. So they are all very focused on open data, because they believe that if you give the data to the people, some people will be smart enough to do something useful with it. But it's not easy. Problem number one, access. Is it a web service, or because it's an administration that knows nothing about computer software, they just give you a link to the file? In general, it's a link to the file. Not great, but okay. Second, format. In general, open data means open format. But sometimes, open data means Microsoft Word. Not great. And even if it's an open or not so close format, it's not super cool to try to scrape data out of a PDF, believe me. And third problem, the standard. Let's say that the administration was kind enough to give us XML. Great. Do you really think they gave you a grammar? And even if they did, probably it's not the same grammar that they used in Switzerland and in France. Or perhaps you know that Switzerland is also a federal state, so perhaps two cantons give the same data in different formats, even if it's XML. So we probably need some standard that is ubiquitous. But you probably know these XKCD comics that if you've got 14 standards and somebody say, oh, I will create one standard to unite them all, in the end you will get 15 standards. And finally, the fun part, and I can show it to you in the demo, is yes, those are hours of the day. Who can tell me what time it is? You know, I'm not a data scientist, but I read sometimes some articles, and I see a lot of them telling, oh yeah, most of the part, like 80% of our job is to curate the data, because the data that we got is really awful. They are not joking. That's true. So once you overcome all those challenges, you might get something. And I became interested in this GTFS. So it's a specification made by Google. Not that great, but it's an open specification for transit information. And interestingly enough, the site itself is Creative Commons, and the code snippets inside are Apache license, so you can use them. And they define two things. They define the static model, and so I won't read it, but I mean, you can define the stops, you can define the routes, the trips, blah, 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 everything. You've got a lot of them. And you've got the dynamic model. Cheers. Again, I won't read everything, but it's just to show you that it might be a bit complex. And now I want to use that to display all the Swiss public transportation. Great stuff, it's open data. Even better, it's GTFS. So I downloaded the file, and now I can call a REST endpoint and get the dynamic data. And when I call the dynamic data, I don't have the whole data model. So before, yeah, the screen is a bit small, but I had this vehicle position here. Great, cool. Now I use this and I don't have the vehicle position anymore. And that's where data streaming comes in. So here, what I get is what they call a trip update. And a trip update is a collection of stop time updates. And basically, they tell me, you know, regarding the timetable that was planned, the 5th stop we will be 60 seconds late. So I need to think, okay, so basically, this stop normally is located at this position, and they will be there at this time. I have the previous position, I do the same, and now I can interpolate between the two. And that's what I'm doing. So the source is a web service, and I split every call. The trip gives me like a huge JSON, and I split it into like different trip updates, and I enrich it with the trip data that I loaded previously, then with the stop times data. I got the hours into the timestamp because my front-end developer wanted to use timestamps, and then I get the location data and I put it in the hash map, like distributed hash map. And this is the architecture. I have the streaming engine. This box is a streaming engine. The first thing that I do is I load all the reference data that I previously downloaded. So I send the job to Jet that will read the files and store everything into my EMDG. And once this is done, and it takes a bit of time because the files are quite huge, so I already did it on my machine, then I can send the dynamic data loader. And this is a job that will call the REST endpoint at regular intervals and do the processing that I've shown you in the slide before, store everything in a different table in IMDG, and I have my web app that registers changes. So every time there is a change by this job, then I am aware of that and I can react to it. And then I can send it to a WebSocket. And again, on the front end, I register to this WebSocket, so every time there is a change, then the WebSocket endpoint, the front end, the JavaScript can react to it. And it's time for a demo, so just that we are on the same page, the last time I did this demo, it was a failure, a huge failure. So just to manage the expectations, the good thing is since that time I learned about it, so I did a movie. So even if it doesn't work, now I can show you the movie and not look like an idiot in front of you. Like, because if you cross the Atlantic to look like an idiot, it's not that great. Is it big enough? Here I cannot make it bigger, unfortunately. So I have my two main jobs, like the load static stuff that already was executed, and the stream dynamic one that I want to show you. Before, perhaps I can use Postman just to call the web service once and see the JSON payload that it returns. No internet connection, that's not good. I want an internet connection. And now, yes, great, send. So I'm asking about the latest dynamic data, and it gives me this stuff. So for example, when I say I want to split, here I've got a lot of like stop time updates, and I want every time to split it. It's long, I won't go to the end, it's really, really long. So here I have another trip update. So the first thing is to split them into different entities so each of them can be processed. And as I mentioned here, every stop time update has like a delay regarding the departure or the arrival. So here, since it's the first one in the sequence, it's deported on time. But here, even though it's the second stop, then there is already like a 1 minute delay when it will arrive at the next stop. And here you can see I have no clue about the location. That's why I will get the location from the stop ID that was already stored in the MDG. The fun stuff, it's sometimes also, it skips a sequence. So here it's good, yes. Here, for example, stop sequence 7, stop sequence 9. And the 8th?
Maybe somewhere else.
Maybe it just disappeared. So what I assume here is that if there is nothing, I assume it's on time. Because I already have the trip. So I say, okay, if it's the 8th, it will be on time. So I will stream the data live. Ta-ta-ta. So now it has sent the job here. So you can see that I've made a call to the web service and I received the result. I've split. I've handled all the process and every time I output so to be sure that something is working. Now I will run the application. It works. Amazing. The routes that are in gray are not used at the moment. The routes that are in red are used and are trains, and normally at some point there should be green ones that are buses. And you can see that if I will go a bit closer, the interpolation is done on the client side because that was a bit too much. And this one is the Interregio 15, and it should go to next one, Zofingen. Yes, Zofingen. Here I am limited by the front end. Like if I let my Spring web application like send everything it can, at some point the front end says like cries uncle and say, hey, you are sending me too many events, I cannot follow anymore. So I'm introducing a slight delay, but of course then it's not that good. Then the map takes a long time to load. So after some time, you can have something like this. I will show the video because now you've got everything here. Okay. So here, I've let it run for a long time, and you can see you have green lines, you have red lines, you can see the name of the stations that I've shown you, you can see the name of the transport itself, and you can see it like slightly moving. Of course, right now it doesn't follow the exact rail station because I'm not good in front end and my colleague didn't have enough time. So if you are interested in contributing, I will be super happy if you do, because I have no clue how to do it. But I mean, it's a good approximation, I believe. So let's get back to the presentation. streaming has a lot of benefits. I've tried to like highlight. Of what I've shown you to do that in California. Here are the specification, and here is the GitHub repository. So if you want to fork it, I will be happy. If you want to contribute to it, I will be super happy. And now I have a couple of minutes for questions, and I will be happy to take them.
Have you ever reached out to the providers of the data to see if you could answer the question as to why that one stop was missed? Or do you just deal with the data? Do you just roll with it?
I'm a developer. I don't talk to people unless I'm forced to. So here I didn't reach out to them, and I just assume it's like that. And besides, I don't care that much. It's a demo. But yeah.
So working? So I know Hazelcast only as like a caching product, essentially an in-memory database. Is Jet just like a append-only type of data store that's been added onto it, or?
No. So first, just we offer an in-memory data grid that most people know that they use for caching, but we have a lot of other use cases. I will probably need to write a blog post about that. We don't only have an IBAP, you can have queues, you can have locks, you have atomic longs, you have a lot of stuff. Okay? Now, about your question of Jet, it leverages the in-memory data grid, but it still runs in memory.
So there's no, storage component to it? Or?
There is no storage. Nothing prevents you from having to write, in the end, you sync to Kafka, or your source is Kafka. The point of Jet is to do like stream processing very, very fast. As soon as you go on disk, you can keep the data, that's great, but you are much, much slower. So it depends on your use case. One of the most, where we are really, really very good is in fraud detection, for example. We have a lot of financial institutions using Hazelcast Jet for fraud detection, because you don't really want to keep the result in the end. What you want is to have very, very fast result, so when the customer gets the result very fast.
Processing.
Yes, stream processing, yeah.
No, I'm processing.
You're processing. I can stay a couple of minutes afterwards, though I have a flight, and if you, once you have processed everything, if you have more questions, I will be happy to answer.
I actually work in fraud detection, and I would argue that we absolutely keep all of the data so that we can use it later for retraining models.
Okay, yeah. Then that's also a very valid use case, but then it's a trade-off.
I had a question about idempotence. Are you enforcing that? Is that a thing that's handled, or is it something you just have to know and do that?
No, we have at least one semantics. So basically, if you send the same data twice, it's up to you to like define a unique ID and to say, oh, I already processed it. Or you don't care. Again.
Use case.
Yeah, use cases. But yeah, I mean, we try to be as simple as possible because we want to be fast. And if you want to be exactly once, it's a lot of work and complexity.
Indeed.
Are you familiar with the German transport company Flixtrain and Flixbus?
Nee, bin ich nicht.
Okay.
No, I'm not.
Okay, that's okay. They have recently expanded into the US, and I noticed that they have an API for their data, and I wondered if you knew if it was in GTS format. So
No, I don't know.
that's okay. All right, thanks.
I do actually think that LA Metro does publish data very similar to this, and you can actually have an app that shows you where the buses are on the map and where they're going to get to.
Yeah, and the most important stuff is even if it's the same specification, probably you will get different data. Here, you know more or less, and you need to process everything to like infer the location. But imagine that you have GPS like chips on your trains or whatever, then you can have the real locations in real time, and you don't need all that. Perhaps you don't even inject in that case. And that would be pretty cool.
Any other questions? Well, thank you very much.
Thanks a lot.
I'm glad everybody was able to brave coronavirus to come on out. We have another talk at 3:30 with discussing Kafka and making sure that data is, to idempotence, is that it is that the data is arriving properly and in a proper order, which is actually a huge, very difficult problem. So hopefully we'll see everybody very shortly. Is it 3:30? It's actually at 3. It's at 3 o'clock.
Also ursprünglich habe ich gedacht, dass du
Hello? Hey, everyone. Sounds good, Mike. This is pretty loud. Like normally I speak loud. I don't know if I need this.
There may be a volume on it.
Volume adjustment would be good. Maybe I could turn the thing. Hello, hello, hello. Hello, hello. How you doing? Welcome. Welcome to my workshop. Here, have a sheet of paper. Welcome. How's everybody doing today? That's good. That's good. That's really good.
Yeah, no, I didn't have any place to sit down, so I just came here.
This is a great place to relax. I can tell you all about Kafka. It's a fantastic technology. Fantastic. Should I turn it off?
which you are. So
No. Kafka.
Kafka who?
Topic 2.
Partition 1.
Out of order. Kafka.
Kafka's out of order? Uh-oh. What do you do? What do you do?
What do you even do?
I don't know. That's what we'll talk about today.
Keep it in one string.
Nice. All right. Show of hands out of the 6 people in this room if you've heard of Kafka before. 1, 2, 3. Is that 4? 5. Okay. Maybe I actually don't need to cover the 10 slides saying what Kafka is, but
No, for the hundreds.
oh yeah, the 100 people. Hi, how you doing today? So, I mean, I don't know, everyone knows the LinkedIn story. Basically, they invented Kafka because they had a lot of stuff talking to each other, and they wanted a simplified architecture, unified log, right? Beautiful, elegant, simple solution. So, yeah, they have a cluster of about 1,400 brokers, 1.4 trillion messages are all Avro encoded, and they use it for basically interconnecting different things. So why would you consider Kafka? Well, I think no one in this universe wants monolithic architectures anymore. Everyone wants a microservice-based approach. People want to write Kubernetes containers. People want to write simple, modular solutions. So obviously there are some advantages to microservices, right? You can distribute your entire workload. And if you want to do a microservice-based architecture, you need a event-driven system. And event-driven systems are very good for business because you can have multiple divisions with multiple databases, multiple data systems talking to a centralized distributed platform called Kafka. So what is Kafka? Again, most of you actually know what it is, but you have topics, brokers, clusters, zookeeper, topics, partitions, records, etc. So this is kind of what a Kafka cluster looks like, minus your zookeeper. So just forget about zookeeper for a second. But you have the producers which send data to the Kafka cluster, which go to topics, and every topic is composed of one or more partitions. So Kafka messages always contain, a key and a value, and then some metadata. And metadata is something that either you can manually create, or you can just let Kafka do its thing and put it where it belongs kind of situation. Here's another diagram of Kafka. So producers push to Kafka, and consumers pull from Kafka. So it's a pull-based architecture, not a push-based architecture. All right, so let's talk about the subject today, which is how to preserve your data order in Kafka. I know if any of you have ever worked with Kafka before, you might have something where, So messages are sent by a producer to a particular topic. However, data in that topic is guaranteed to be ordered only in that partition. So if you have like a 5 partition topic, all your data is guaranteed to be ordered in just one of them. That's kind of a way of seeing it. And a consumer instance will only be able to see records in the order they are stored in that partition in general. So this is kind of what it is, right? All the data goes in order on the topic. Producers write to the end of the topic, log segment in a partition, and consumers read there with different metrics for offsets. And here's the anatomy of the topic, right? So all your data is essentially going to partition 0, 1, and 2. Now if I had 3 consumers, they're going to each read their own partition. Or worse, if I just had one consumer reading from all of these, they're going to get all the data in partition 1, then all the data in partition 2, then all the data in partition 3 in that order. That could be a good thing or it could be a bad thing. It really depends upon what you planned for. So what happens if you send data to many partitions? So I'm just going to create a simple partition. By the way, I could open up a terminal and do this, but the command's right here. You create a topic, 10 partitions. 10 partitions. Now what would happen if I were to simply send it the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What would happen if I spun up one consumer and had it read from the beginning of that topic? You know, set the offset to earliest. What do you think would happen, Mark? How many partitions are here? 10. One consumer. What do you think would happen? I'll show you exactly what will happen. Your data will come out in some random wishy-washy format, because when I sent the messages, there was no key. There's 10 partitions. So that's why the data here is going to come out like a data pile of junk. So, yeah, there you go. When you're a producer, you're sending your data to all these nice, organized 10 partitions. Each one has its own number. And when a consumer subscribes, they're randomly assigned partitions. So what happens if you send data to one partition? We just create the same topic with just one partition. And we send numbers 1 through 10. What do you guys think happens? There you go. Exactly. One partition. Kafka guarantees its data in order for a single partition. What happens if you introduce the concept of keying? That's right, it does kind of this stuff, right? So messages sent by a producer to a particular topic partition will be appended in the order they are sent. So all messages with the same key go to the same partition, always. So suppose we want to send 4 messages to a Kafka topic with 2 partitions. We have 4 keys: Costco, Walmart, Target, Best Buy. The keys are hashed and distributed across the cluster. Right? Now suppose you want to send 4 messages to those 2 topics. Where do you think they're going to go? Where is Costco going to go? Which partition? 1? Okay. What about Walmart? Okay. Target?
2.
Best Buy?
2.
There you go. Pretty straightforward. What if I add one more partition? And then what if I do a rebalance of those partitions? It'll distribute the data nice and evenly. Not this doesn't happen automatically, by the way. You have to, run a command and stuff. But if you set it up at the beginning correctly, this is how your data would look. So we're going to send 4 more messages to a Kafka topic with 3 partitions, right? Costco, Walmart, Target, Best Buy. So everyone, take a look at the previous diagram. Lock it in your brains, okay? Where do you think Costco is going to go? Where do you think Walmart's going to go? Target. Best Buy. There you go. Does this look like a balanced? No, it doesn't look like a balanced. You have a lot of log segment files in partition 1, but partition 2 and 3 would look pretty light. So in this situation, you want to make sure that the number of partitions matches the data distribution you anticipate. All right. So how do we make sure our data is always sent in the correct order? So messages sent by a producer to a particular topic. Okay, I already read that. So here's kind of an architectural diagram of what a Kafka producer actually does, right? Producer record is like a method to create a producer record. So if you're writing some Java code, you do producer record, you give it a topic, and a value you're going to send it to. Now optional to there is a key. Always send a key. You do have the option to explicitly write data to a partition. The producer class will then serialize it, either using Avro, JSON, byte array, if you're using like a mirror maker. And the partitioner class will assign the data to partition 1 or partition 2. which will then try to talk to the broker. And if there's anything, it'll try to retry or it'll throw a record. So here's a nice little workflow diagram. So in the old school days of Kafka, you would actually kind of tweak the setting, which is called the maximum in-flight requests per connection. That's a mouthful of a word, but let me explain it. So basically it sets the retries parameter to non-zero. And when you have this parameter, max in-flight connections, that means you could have like more than one asynchronous thread running. And if one of them fails and the other one goes through, then your data can go out of order because the first message failed, the second one went through, then the first one goes, it'll pop in here. So usually setting the retries to 0 is not an option in a reliable system, so if you want to guarantee the order, set the maximum number of asynchronous requests to Kafka to 1. Now this is kind of an old school recommendation, but it works. So, Kafka delivery guarantees. At most once delivery, it guarantees that a particular message can be delivered once or not at all. There can be a loss of messages, but a message can never be delivered more than once. At least once delivery guarantees that a particular message will always be delivered. It can be delivered multiple times, but there will never be any lost messages. Then there's exactly once, right? And that guarantees that all messages will always be delivered exactly once, and exactly once does not mean that there will be no failures or retries. They are inevitable. An important thing is that the retries succeed. In other words, the result should be the same whether it has succeeded, processed exactly once or not. So, what is exactly once delivery? So, independency on the producer side can be achieved by preventing messages from being processed multiple times. This is achieved by persisting the message once. So if independency turned on, Kafka message gets two things, a producer ID and a sequence number. And the producer ID is completely transparent to the users. And the broker will automatically deduplicate any messages sent by this producer, ensuring independency. Okay, so then you also have partitions, which will ensure that each message gets processed exactly once. Transactions can be used. The transactions have an all or nothing approach. They ensure that after picking a message, that the message can be transformed and atomically written to multiple partitions and topics along with an offset of the consumed message, which is the transaction coordinator and the transaction log, which maintains a state of atomic rights. Then you have a consumer. If a consumer is transactional, then we should use the isolation level, which is read committed. This ensures that it only reads committed data. The default value of the isolation value is read uncommitted. So if you wanted to enable end-to-end transactions in Kafka, this is when you use exactly once delivery. All right, so here's a nice little complicated workflow. Step 1, yes, which is a register, middle of the screen. So it registers a transactional ID with the coordinator. Step 2, the coordinator bumps up the epoch of the producer ID, so the previous instance of that producer ID is considered a zombie and fenced off. Step 3, the producer adds a partition with the coordinator when the producer is about to send data to a partition. Step 4, the transaction coordinator keeps the state of each transaction in its own memory. Step 5, where's step 5? Down there, bottom left. Step 5, the producer sends data to the actual partitions. Step 6, the producer initiates a commit transaction, and as a result, the coordinator begins the two-phase commit protocol. Step 7, which is on the prepare side, is where the first phase begins, and the coordinator updates the transaction log to prepare commit. Step 8, which is at the very top, the coordinator then begins phase 2, where it writes the transaction commit markers to the topic partitions that are part of the transaction. And after writing the markers, the transaction coordinator sends the transaction as committed. Wow, that's a lot of steps. So this is kind of the diagram of how the exactly once semantics works. So to implement transactions, you basically ensure that the number of messages produced and consumed are atomically. You basically have the transaction coordinator, which sits between the consumers and the brokers and the producers in the transaction log. You have the transaction log, which is literally just, working for the transaction coordinator. And you have the notion of controlled messages, the notion of transactional ID, and then we finally introduce the notion of producer epoch. So the transaction coordinator, it's similar to a consumer group coordinator, that each producer is assigned a transaction coordinator, and all the logic of assigning the producer IDs and managing transactions is done by the transaction coordinator. So a transaction log is similar to the consumer offsets topic. The transactional log is persistent and replicated record of every transaction. The transaction log is a state store for the transaction coordinator with the snapshot of the latest version of the log encapsulating the current state of each transaction. So control messages are special messages written to user topics, processed by clients but never exposed to users. They're used, for instance, to let the broker indicate to the consumers if the previously fetched message has been committed atomically or not. So a transactional ID enables users to uniquely identify producers in a persistent way. Different instances of a producer with the same transactional ID will also be able to resume or abort any transactions instantiated by a previous instance, so you can roll back or commit forward. And then finally you have producer epoch, which enables us to identify if there is only one legitimate active instance of a producer with a given transactional ID, and hence enables us to maintain transactional guarantees in the event of a failure. There's one more interesting concept which I'll cover here. It's not in my slides, but it's a new thing that came out in Kafka 2.3.1. I want you only to pay attention to one thing on the screen, because it's not on my slides and I just thought of it now. You have a topic, you have 10 partitions. In Kafka 2.3.1, they've introduced a feature called sticky partitions. What this means is a consumer can be guaranteed to always be reading from that partition, or always read from this partition. This has solved two very important things for the industry. One is you don't have the rebalance issue. Everyone's had to deal with a rebalance before. It's pretty annoying. But the thing that gets me excited, very excited, is that consumer will be reading from the same partition all the time. Wrap your head around that for a second, because if you do something like sticky partitions, that also guarantees the consumers will be reading guaranteed order for that partition, because they're always reading from a partition, not just a topic. This is not in my slides. Whoever's watching in the recording will have to remember that, but there you go. All right, guys. I prefer interactions, so this concludes my talking point. Let's answer any questions you have. Let's make this fun. Yeah, they're already uploaded. Come on, go ahead, come on.
So in that last case you were talking about?
Yep.
Where you're just reading from one partition, and if we'd sent the data to the 10 partitions, would it just get one of the values?
If you had 10 consumers,
Yeah.
yeah, it would only read one number though. It would only read one number.
Yeah, if I just had one consumer, would it just read one number?
I think so. I think so.
Fascinating. Okay, cool.
Kafka is a wonderful world of whatever you want. It's very, very flexible. Go ahead.
Can you talk to some real-world applications, how Kafka is used, and maybe some examples of how we go about using it?
Yeah, so Kafka is the ultimate microservices architecture. This is kind of like the diagram in a nutshell that enables it, right? You have different divisions in your company that handle ordering, billing, inventory systems. They have like legacy, or well, I don't know if it's legacy, but an Oracle database. They might have a Mongo. They might have a MySQL, a Redis, a Cassandra, all sorts of junk. And you need to somehow centralize all these processes and talk to different divisions without going through managers or whatever, sending emails. But, you know, we're engineers. We engineer solutions. So what's nice about Kafka, it provides a standard gateway. Because Kafka doesn't care about the format of the data you send it. It's literally just, you know, log segments and bytes. If this was SQL, you'd have to write SQL. You'd have to write stored procedures, you know, all this stuff. Redis is in memory. You only have so much memory. Mongo's amazing. I love Mongo. I don't know, some people don't like it. But Kafka's good because it's a distributed platform. So if you need to horizontally scale, it's designed from the get-go to be pretty much leaderless and homogeneous. So it'll just scale, you know, infinitely if you plan things accordingly. Did I answer your question? Okay, go ahead.
One thing. Sorry. My company actually does use Kafka as part of our data stack, although we do at least once because we dedupe. But one thing that can always be annoying also, that's like another small gotcha, is obviously, assuming you care about the data going into Kafka, you're probably going to have a replication factor, which also means you need to be very careful and make sure you tune your minimum in-sync replicas, as well as I don't remember the parameters off the top of my head.
You're correct. You're correct. When I give demos, sometimes I like to switch off brokers, and if I don't tweak that in-sync replica to be like 1, it's usually by default 2. So I'll kill 2 servers, and then I'll start like sending messages, and like I don't know why it's not going through because the in-sync replica is not low enough. So if you want to survive failure and recover faster, lower your in-sync replica. But if you want to make sure your data is replicated fully, best practice says to match your in-sync replicas with your replication factor. But whenever I give a demo, I try to reduce that min-sync. Yeah, cool.
But it's definitely like a small gotcha where it's also like a performance gain for resilience gain. And of course, your priority, if you're like, okay, fine, I don't care if I lose 1 in the case or a few small stack if things die, or in another case, like, no, this is financial data. I can't lose a single one ever. I'd rather the system have to just freeze back up until I get it back up. You have to actually make the decision on the ordering.
So another thing that one of my clients is doing in Chicago, major financial exchange, they actually had like thousands of topics with single partitions. I know, right? But it worked for them. They could, go ahead. Yeah, pass him. Yeah. Guy with the motorcycle hat,
That leads
go.
into my question, which is, can you talk about like a philosophy or methodology for configuring your partitions? Like how many you would want?
Yeah, so I'll tell you what I advise people, and it's contrary to what most published information. You want at most 1 partition per CPU in your cluster. I mean, that's it.
Our philosophy at Ticketmaster, we use Kafka heavily, is you need only 1 partition.
He's got it. He's got it.
And period. And then if you start to see that you have problems, then you might go to 2. We had this problem where internally we had one team had configured a Kafka topic. This is 2017 Kafka.
Nice.
And they had 15 partitions. But they needed it because they were recording every single thing that everybody did on our website. We have, 80 million unique viewers per month.
Wow.
And so there's a lot of activity on the website, so that needed 15 partitions, 16 partitions. The problem was that other people started to adopt Kafka in the company, and they just whole hog copied the config. And so now you had these data producers that were producing maybe at peak a couple hundred messages per second, and they needed at most 1 partition, maybe even half a partition, frankly. And you can't have half a partition, but like they just didn't need more than 1. And so like they were like, why are my messages behaving so weirdly? What's going on? And so the answer is 1. You need 1. And
I actually have an example of that when we were first setting up the Kafka partition, because I was trying to figure out the configurations, and I'd never touched Kafka before.
There you go.
And some default somewhere is like 64 is a great number. Yeah, I
Oh my
kid you
God.
not. I wish I was making that up. So it was, and I was like, I guess, sure, whatever. Well, what we do with it is we just use it as a transit store, so we then ship it off to S3, and they get labeled, so each partition becomes its own file of a segment. We don't entirely care about order because they're sorted in our method of ingesting it.
That's good,
so
yeah.
we do dodge a lot of the normal pitfalls that your talk is talking about addressing, but we dodge it in a different manner.
That's
But
good.
here's the penalty here. So whereas if this had been one partition, which wouldn't work for us, but if it had been one partition, then we would have had one file uploaded to S3 every 5 minutes or 2 minutes, depending on your rate. Well, there were 64. Well, there's a certain amount of overhead when you need to download this data out of S3 per file, as well as listing it all out. And maybe it made some things that should have taken 10 minutes take closer to 5 hours until we had to shrink it all back down. So it's very important to figure out what you actually need as opposed to just what some random recommendation is somewhere, because you'll get these recommendations. Yes, your Zookeeper node needs 16 gigs of RAM. And I'm like, our Zookeeper node I think has 4 gigs, and I've never seen that thing work hard a day in its life for Kafka, because we gave it its own special stack, because I don't trust it not to knock something else over.
Oh yeah, I mean, back when I was doing Kafka, all the messages were stored in Zookeeper, and it was just so interesting to like figure that out. But that's like one of the things they changed. I was glad they did. Yeah.
We actually had a problem last year where somebody had also managed to obtain the 64 partition default somewhere.
Oh God.
And so there was this team that we were dependent on. I work in fraud, and we were dependent on this upstream team, and they were producing. This is one of the reasons why I thought this talk was so interesting. Is that they were producing the data, and it was a particular type of data that had to be delivered very timely. And their SLA, their stated SLA, was 5 to 10 seconds, which was like that. Kafka should be able to like super easy to handle that. What was happening is when we actually started reading things, if you read using like Kafka Cat or the Avro consumer or whatever, whatever consumer you have, just sort of out of the box consumer, we were seeing, within 5 seconds, within 5 seconds, within 5 seconds, 20 minutes old, within 5 seconds, within 5 seconds, 40 minutes old, within 5 seconds, 2 years old, within 5 seconds. It was just like, what the hell is going on? And it turned out that because they had spread it out over 64 partitions, some of those partitions would just sit and wait until they reached a certain capacity before they published their messages. And so some partitions were kept up, and many partitions were lagging by a great deal. And because they were lagging by so much, they couldn't even hope to keep up their SLAs, right? And so it became a huge engineering problem. We just ended up having to switch to a different team to consume from. So start at 1. That's like you need 1, and then you go higher.
So I think it's way better than my advice, which is usually like 1 partition per CPU in the cluster. But 1 partition, that's perfect. You guarantee your order, and it's usually fast enough.
The only one thing I will say on the partition, because we had disk space limits on them, is do you realize you can only split your partition is also your division? So if you have 1 partition, that means each server must have the complete copy of all of your data sets. Yep. Whereas if you have 2 partitions, potentially that could live on 2 different servers. So, it allows you to divide up your data. So you do need a balance there as well. The last thing on partitions on why you might need to increase it.
Okay.
But you have the replication factor.
Yes.
Right, so if you have 3 brokers and it's replicated, then even if a broker goes down or your one machine goes down, you can still consume from the other 2.
Yeah, but I mean, it's just having if you only have 1 partition, then it's 3 copies of 1, whereas suppose I'll have 4 boxes with 3 replication, or sometimes I have to tune it down, whatever reason. But so then there's any box only has about 2/3 the total data, so it lets them have a little more disk space. I mean, it only matters if you can't have a terabyte of disk or something.
There is a reason why, if you're going to roll this out into production, you generally need at least 1 dedicated operations person. It is one of the overheads of running Kafka is that This is all battle knowledge. Like these are all things that we've learned because of
The hard way.
things that have gone very, very badly wrong. And we have internal, like at Ticketmaster, we actually have internal documentation of best practices that nobody pays any attention to. I'm being a little cynical. Some people do and some people don't. And then you just have to keep hammering home, and you need to have a team that helps. Like the larger it is, the more you have to manage it. Netflix gave a talk to us where what they do is they have everybody who wants, is anybody here from Netflix? Oh yeah, so if they were, they could speak more intelligently about it than I can. But what they do is they actually have a system that allows you to create your own Kafka cluster and then have your own thing where you communicate within your team. And then if you need to talk to another team, then they have a larger cluster that connects to the other clusters. And it's a very complicated infrastructure. What it means is that one team can do their own stupidities locally and not screw up what everybody else is doing. But they invested a huge amount in having that level of redundancy within their organization. They also are moving petabytes of data through Kafka. We don't.
So another interesting talk I gave recently was on disaster recovery. And so Netflix had a lot of small clusters, it sounds like.
From my recollection.
Okay.
Like I said, like they'll be able to speak more intelligently to their own stuff. But.
I really wish we had someone from HubSpot in this room. They had one giant Kafka cluster, and their zookeeper had a split brain problem. So half the zookeepers had the metadata here, the other half had it here, and then they had this split brain issue, and it was a total disaster. They were down for a few hours. But in that case, they had one production supercluster. So generally, the things I advise are small clusters, team-oriented, and then you can transport messages between them for that kind of risk.
Yeah, it's usually not worth the risk. I found because at first someone wanted me to, at first someone wanted, for example, at my place, we already have Zookeeper for various types of orchestration, some configs, mostly old configs that still grumpy about, but that's a different topic. And they're like, yeah, just throw Kafka on there. It'll be fine. And I looked at, while we were benching, I looked at some of the spikes in Zookeeper load and stuff like that. I'm like, there's one problem. If this goes south, everything else that is dependent on this Zookeeper cluster is going to die horribly. Especially since Kafka, if you have a whole bunch of partitions and a whole bunch of consumers, that's a lot of connections, and these start adding up on Zookeeper. And people, especially, and even at the base level, you're like, oh, this is fine. Well, when it disconnects and reconnects, you end up with double the number of connections for a little while. So you thought you were fine at 60 of 100. All of a sudden it needs 120 of 100 because some hiccup happened in Zookeeper or something, and now your Zookeeper is rejecting a bunch of servers and you're down.
I once made the mistake recently where I set up just like 28,000 partitions on my laptop. It's like a little laptop cluster. Or I don't know, maybe it's a bigger cluster, maybe it's a bunch of medium-sized nodes, and I don't know. But I accidentally created 28,000 partitions, and that was a big disaster, basically. I had to like manually delete data in Zookeeper and manually delete the topics because the tombstoning method couldn't keep up, and Zookeeper was out of whack. I mean, you know.
All right, does anybody else run Kafka in production?
Anyone else trying to learn Kafka?
Do you have particular questions? I mean, it sounds like you have 3 people who've done this, and we can. No, it's fine. No, it's like I would rather that this be, and I think Zeke would agree with me that people learn in the session than.
I want this to be interactive. We have a lot of time together.
Well, I've known about it for a long time, but never used it. And one reason I didn't is because, well, I don't know. It's not normally advertised as a product that offers great latency, low latency. And I just asked what the opinion of that is in the room.
So you could make Kafka be incredibly fast if you turn off replication factor of 3, set your in-sync replicas to 1, you turn off, acknowledgements from the producer, and you don't use transactions. If you turn off all the safety flags, Kafka is just gonna, fly like a rocket ship. I don't know if it'll be as fast as Redis, which is entirely in memory, but that's like the maximum performance you get out of Kafka. I don't know if you guys want to chime in here.
What's your expectation? What do you need?
Well, I mean, trading systems. So.
Yeah, trading systems use
Yeah, actually, we wouldn't use that. We use zero queue. I mean, that's, yeah. So it's just a layer above the socket. Or there's, actual appliance devices like Solace.
Because Redis gives you a pump setup, so you can actually have, things.
But Redis, you have to maintain, I mean, to deal with any kind of volume, you still have to maintain your own sort of backup and coherence. And,
you have a hot swap spare.
Yeah.
But you
so,
get nanosecond latency.
yeah, well.
Yeah, Kafka's
yeah,
not nanoseconds.
From what point to what point? It's in the network topology is another question.
Well,
So.
I imagine if you're doing high frequency trading, you've got everything local, right?
Like C drivers and
No,
yeah.
it's like all along a network topology, which is, what is doing matching, what is doing any calculations, depending on what part you're talking about. And then most of all, shipping it across a wire somewhere. So that's where I just wondered if anyone ever uses it for those kinds of things. I guess not.
You could, but
Yeah.
yeah.
Okay. So.
We will score a transaction for fraudulence within about 500 milliseconds on average in 170 minutes.
That's pretty slow.
And that's doing, we actually do streaming joins using Kafka streaming. I can't tell you the number of topics, but that's a little bit proprietary, but on the order of 20.
Okay.
Come on, guys. This is interactive. Any questions? Good. Don't be shy.
I'm not using this in production or for anything at the moment, but just curious as to how it is being used or what the best use cases or purposes are. What would be a expected time for a message to be held within the queue? Do you use it as like a data lake that they always live there forever, or
No, Kafka is
you'd
going to
expect
store
things to,
data
move
for
through?
like 7 days at most. That's generally the setting. And
You could set it to whatever. We have some topics that actually have retention of 60 days.
Damn.
But to your point, you then have to have a lot of disk space to hold it. So it's up to you. That's a configurable option. We actually have some use cases where Ticketmaster's traffic is very bursty, and on certain like that, the one I was telling you earlier, the everything that everybody does on the website, that we only have retention set for 1 day. We don't have retention set for 7, because 1 day is like redlining certain parts of the system. So, yeah, that's at a topic level. Topic level sets the retention period.
We also set various monitoring on our Kafka stack. So I'd set up it's a very primitive, simple disk alert, which is if the disk space changes by more than 10% in a day, since the retention is 7 days, I'm like, start screaming at someone. So that way we can deal with it, whether it's scale up, figure out why something's flooding us, whatever. We have time early on, as opposed to the normal disk alerts of, oh, I'm over 60, or whatever disk alert someone
like an
says.
hour later, you're screwed, basically.
Yeah, but I mean, so that's why I'm like, okay, if disk space has changed more than 10% within a 24-hour period, I mean, usually it's in reality like 6-hour period or 1 hour period or whatever, but still it triggers an alert then, so you immediately start looking going, okay, why is there a lot more data than this cluster will be able to handle for a long period of time? So it's also very important to make sure you catch that early, because if you catch that late, rebalancing takes time. Can be a fair amount of time depending on the amount of data. So if you don't have monitoring that gets you to be aware of a problem with enough time to deal with it, your cluster may fall over before you're done. So,
To your other question, why do this? What this enables is there's a couple things there. One is that you have a producer, and the producer can be on a different team than the consumer. So the producer says, like the consumers and the producers will have their product managers, and usually what's going to happen is that there's one use case where one team says, hey, you guys are doing something. I want to know what that is. I need to know the messages that are going to come out of there. Like maybe you're doing click tracking, maybe you're doing purchase tracking, maybe you're doing whatever the hell it is you're doing, right? I want to consume that, and I want to be able to do stuff with it. But you guys can just give me the data and then whatever. Like it's my job to do something with it. And so what happens is then that the producer and the consumer, the product managers generally have a conversation about what that data looks like. And you produce it on a stream. Right? The producer just starts pumping messages on the stream. You, through some either shared mechanism, you just decide the retention period, 7 days, whatever it ought to be. That's where you need to have the operations person in the middle who can help tune things for you. And then that producer should be doing things in an Avro format. And this is really, really, really critical. Because what happens is that a lot of times people produce their messages in JSON because they think it's simple. And then the problem is that the producer then changes a message. Or they produce a malformed message. Well, JSON will just let you dump that into the topic and it doesn't care. With an Avro enforcement, there's another server that's called the schema registry. And the Kafka brokers will say, wait, this message doesn't conform to what we know exists. So no, we're not even going to accept the message from the producer. That saves a lot of defensive coding on the part of the consumer, right? Because now the producer can do whatever the hell they want, but so long as they're compliant with their schema that has already been agreed upon, they can add new fields. They can't delete old fields. And you just add in whatever fields you want, and then the consumer can then start to change what they do at their own pace, right? So by adding this Kafka layer in between, you've got a separation between these two teams, and they can start to do things independently of one another. The other thing that you can do, especially if you're doing the keying, as Zeke described, is you can use Kafka streams, and you can do streaming joins, where you can say like, okay, I've got one topic over here where the key is customer ID. And I've got another topic over here that has, information about that customer for whatever reason. Or you've got a, database transaction ID, and here's another database transaction ID. And then you do a streaming join, you say like, if anything happens within a 5-minute window that shares those IDs, produce that message on a third stream that has all the data put together. And we use that extensively across Ticketmaster in a lot of different products, because then what happens is that you then have a bunch of different producer teams, and then your consumers can start to consume from different teams. The producers don't even have to be aware that the consumer is consuming it, right? And so then you can just grab as much data from as many different endpoints as you want and then produce your own machine learning model, your own analytics, your own whatever it is to indicate something to the business, right? So that's a really powerful use case for us.
I had a couple for you here. So like this one, because you got your picture up. For your different data stores, like what are they actually emitting? Is it like bin log type stuff from MySQL, or custom messages that are coming out?
So
for like this particular one?
Yeah, this workflow. If you asked me this workflow like 6 years ago, I would have said, forget about it. That's too much work. But there's actually this wonderful world of connectors. So it's like open source stuff that a lot of different vendors have put together. So if you want to connect MySQL to Kafka or Mongo to Kafka or Redis or Cassandra, you can just turn those solutions going. It's also not that hard to actually just, in your programming language to get like library for X and then library for Kafka, read from X, produce to Kafka, and then that's it. You don't even care. It's pretty nice.
So you could also have like your microservice might be emitting things directly.
Yeah, but you would write to Kafka first because, as Mark was saying, Avro is a good gatekeeper and, security guard for your data. You don't want to send malformed data. It's pretty easy to do that if you're like doing web scraping or anything in data.
And my second one here is how easy is, it's not quite discovery, but if I'm producing data and then I'm not sure if I want to keep producing that data and I'd like to find out, it's beautiful that we're all decoupled between myself and the consumers, but I'd like to know who my consumers are so that I can tell them if I'm going to deprecate my data or change it. Is there a nice way to figure out who's consuming my data?
So at least with the Kafka stack, unless there's a connector I'm not aware about, generally speaking, all consumers are tracked either within. I don't know that they're not all entirely in Zookeeper anymore in the newer versions.
Yeah, they're not.
Unfortunately, one of our connectors still requires an older version, so I'm not 100% on the newest ones. Still waiting on that dang update, but whatever. But you can connect to the Kafka cluster itself, and you send commands to it, and you say, give me a list of consumers. Every consumer joins with the consumer group, and assuming your connections aren't set up terribly weird. So basically, if you're following the actual proper way to make a connector, it will tell you the IP address or the host information of who is connected to this partition on this consumer group, or topic on the consumer group. So you can track the servers that way. If you're talking about like other services, you just kind of have to track them yourself. But
so I mean,
What's the identity?
the simplest way to track the status of your consumers is just monitoring consumer lag. So you can say you're like X number of messages behind in this consumer group. I think that's the question you're asking.
I'm just trying to find out who my consumers might be. My other business group is.
Oh, so usually that's engineering best practices where you name, your topic and your consumer group and your producers. They should have a similar entity kind of thing. I would be in that approach. What do you guys do, I guess?
I think you're talking about how you ID them. Whenever a consumer joins, part of its Kafka configuration is you give it a consumer group name. So that way you're like, oh, this is Secor short store or whatever. If you're using Secor and have a short store versus a long store versus whatever. So you're like, so I need to look at the Secor short servers because that's what's acting up right now, or not consuming for some reason, depending on your monitoring. So the name is very important there. If you use bad names, of course, good luck. But yeah.
We actually have a discipline within Ticketmaster where we have everything needs to have what's called a PRD code. And that's the project code.
Nice.
And we will actually automatically kill topics, partitions, EC2 instances. We kill anything that's on the cloud that doesn't have a PRD code because that's how we do our billing. And so sometimes people forget that and they're like, oh, I'll just create this instance. And then you forgot the PRD code and then your EC2 instance is dead 2 seconds later. And you're wondering what's going on here. And it's because you didn't tell us who you were. Right, but that's because we have 1,100 engineers, so having that kind of coordination is necessary.
It's not by domain or IP. That's not available.
It's not really by domain or IP because you can also have multiple consumers in your consumer group that could be on different IPs.
So consumer groups are basically how you share a workload in Kafka. It's how you distribute the compute capability. And so partitions are mapped to each consumer, and depending on the number of partitions available, then that's how many consumers you can have. And consumer groups are literally applications working as a team. You can have 5 consumers each reading partitions, and they could be anywhere in the world, although it's better if they're kind of in the same location, I think. Yeah.
Where it gets interesting is I had this example, where that you start to need to have more partitions, right, is actually your producer can be streaming along and the cluster can be fine, but then when you have a consumer, if the consumer is doing heavy work for each one of your messages, then either you need to have the consumer be intelligent about how it says okay, I'm going to do heavy work for this, so I need to do my own distribution of work, or you have a consumer group where you have you'd say okay, let's make this 4 partitions so that I can have 4 different consumers in the group and each one of them does something. I personally prefer the first pattern because a separate consumer, maybe not heavy at all, and now all of a sudden you've increased a lot of overhead in your cluster, increased a lot of overhead on your producer, so that one particular consumer who may be just sloppy is now causing some problems, right? But that's where you get the one CPU, handling it recommendation. Does that make sense?
Yeah. So I wanted to ask a question about Avro. Speaking of, resources and latency.
Yeah.
So if you're using Avro, I guess the overhead is considerably more.
Not really. All Avro does is it encodes a message in bytes, and when you receive it or try to send to Avro in the library will basically just, on the producer, it's just a little, if statement that basically says, does this byte array match what we're expecting? Does it have these attributes? Does it have these fields? If it says no, it'll say no. If it says yes, it'll go through. So that isn't relying on a server. It's just a downloaded schema rulebook. It's like a rulebook that you download a rulebook, you have it in front of you, you look through it quickly and you're done.
Right, but it still does add that slight bit of overhead.
It's like O of 1. It's like a simple one-time operation. It's irrelevant for performance.
Okay.
Well, even for there, it's irrelevant because it's that's kind of how I think.
Yeah, I mean, there might be a small overhead, but it's the amount of pain and frustration it will save you from some jackass
Here you
putting
go.
a malformed JSON.
For Kafka users?
Should be.
Should be.
Yeah, I mean, you can.
JSON is not common.
Well, for one client, I actually set up like JSON schema, which is like Avro, because we are integrating with, what's the name of that Node.js API? I forget. Anyway, for some reason, they needed to use JSON instead of Avro, but I made sure that they used a schema type tool. In general, I would enforce Avro schema because it's Avro's the best. I'll just put it that way. Avro is literally just like.
No, I know what Avro is, but you're saying you, with your JSON people, you had them set up a schema, or you set up a schema. What does that mean?
In broad terms, you can send a message in any format you want. You just need to validate it against a rule book, and that rule book is defined in JSON. Yeah.
Right. And what the Avro will do is there's a separate server that's a schema registry that tracks the Avro schemas, and when you update it, it'll keep track of that. And so you could say, like, this is actually, Avro schema ABC version 2. And so there's actually bytes at the beginning of the message that specify what to look for, and that's how the server, yeah.
I mean, I had a couple financial clients, but I don't know if they were doing it for like real-time trading analysis. I think they were using it for like storing trades. Yeah.
Without getting into too much of a religious argument, is there a reason, or in your usages, why Avro over Protobuf over whatever other?
Protobuf is fine. Yeah, it's totally fine. Protobuf is like, Protobuf is like encoding messages with, I forget, it's like basically two methods, and that's called Protobuf. That's what I remember. You can use any encoding library of Kafka. That's why people like it. Like, you could do raw bytes. You could use JSON, Java objects. You could do, XML, JSON, Avro, whatever you want. Just best industry practice to save everyone a lot of headaches is to use Avro. So if you're hiring like a junior engineer, the right code that just sends data into Kafka, it could be like, bad data, and then that would break other work down in the pipeline.
So you could bypass any of this validation.
Yeah, of course. Kafka by default doesn't care. It's just, Mark and me who've worked in Kafka for a while, it's best to introduce something more authoritative, and then in like the more senior people go, we don't need Avro. But when you're first adopting it, you want to build that best practice advice. And when you implement it, it's just a message encoder. Like, you don't have to actually use it on every single application. You could have like one topic that's Avro, another topic that's like images, etc. You want the microphone?
No, I'm done.
All
right. Come on, guys. Any more questions? A couple quiet people here.
He raised a really interesting point. Another reason why to use Avro actually is compression. Because Avro is a binary format.
It compresses,
right?
Like, if you were to send a JSON packet over the wire, that's a big JSON document, but Avro just like,
it's like 10, it's like 10 to 1, depending on your data.
Imagine just you're sending a Word document as opposed to a zip file, except your Word document's big.
Yeah, I mean, if you don't have any control over, what gets put in.
The only time it gets annoying is if, you're using like some kind of tool that can't connect to Avro. So if you're not using Avro, it's easy to read Kafka topic because it's JSON, but a lot of tooling out there makes it easy. But Avro is pretty much the way you want to go, if you can do it.
Yeah, I don't know if you guys do this. It's just like one of the tricks that I've just picked up over the years is like I have a notepad that has like commands that I've just sort of like memorized, or it's like I need to connect to this server and do this thing, and so like I'll have the like 5-line command, and it's just in that notepad, and I can just copy and paste it. I do that with Avro because with Kafka because there is a Docker image that will run a command line tool to consume from a topic, and so if you're like, I'm always consuming from this topic and I want to run this experiment, and I consume from the topic and I dump it to a file.
Nice.
And it's, it's going to be like Docker run image name this, like here's the thing, here's the thing, here's the thing, like here's what my zookeepers are, here's where my broker servers are, here's where all this stuff is, here's where here's the Avro schema registry is all here. So it's like 5 lines long, and I just have it, in that copy paste thing. And then I could just sit there and listen to the topic. And that actually helps because what happens is that a lot of people will do the standard monitoring that you put on your Kafka topic is a sort of standard, hardware monitoring, right? Like memory, disk, network, what's the last one? CPU, right? You just do that. And then lag is another one, right? But a lot of times what people will do is they'll actually have an ELK connector, right? So you have your Kafka going into ELK. And then you look at your results on Kibana, and there's very standard connectors to do that. But sometimes your connector screws up. And so it is helpful to be able to sit and listen to the topic using a command line tool, and then just say, wait a second, do I have a problem in my ELK stack? Or do I have a problem in my thing? Like it's just a very useful, handy way to debug stuff.
Yeah, the ELK stack and Kafka go very nice together though, because you can pump Kafka data into the ELK stack and you get your Kibana dashboard. It's pretty cool.
Yeah.
It can also be very good for having a temporary. It can also sometimes Kafka can help if you need at least in the earlier days of ELK, there's big problems where you have to make sure you throttle what you're throwing into that. In some cases, I mean, it depends on how much money you're throwing at the problem, to be frank on that. But so you can use Kafka sort of as a buffer, and you can always set your consumer that you only send these rates, and then you can, after you get your ELK stack ready, you can tell your consumers to speed up and whatnot. So it can act as a temporary data store. Also, if I don't normally care about these logs going into ELK, but you're like, oh, some CRUD happened. Since if your logs are passing through Kafka, assuming they're still living within it, you can make a new connector or a new consumer and go consume it and funnel it into ELK now, and it'll give you whatever the lifespan is of the Kafka, depending on how you set your parameters there. And you can be like, okay, great. Now it's in an ELK stack. I just grabbed 7 days, where normally I don't care about putting this in ELK for whatever reason, and now you just have it there.
Nice.
So it lets you it can give you some flexibility there. I mean, these are kind of oddball cases, but you never know what someone's going to end up using a tool for, so I try not to presume that even if it sounds a bit weird, that someone might find a case where no, this is the greatest thing ever for me, for whatever reason.
I missed what Instacluster was.
Oh, yeah, well I have pages here on what we do. Here you go. So basically what we do is we're just a scalable managed service company. So we work 24/7 on open source technologies. We don't have any licenses, and we basically solve any type of Kafka related issues that you might have. I'm on the consulting team, so I'll just go on site and write some code or look at some stuff and provide expert advice, but that's our business model. Yes. No such thing as last questions today, by the way.
As a very, very small team that's probably not ready to invest dedicated resources to Kafka, but we'll know, or we think that we want to use it in the future, what would be a service that you would use in the interim?
To get started with Kafka?
To get a Kafka-ish kind of level of experience or service level. Maybe not a Kafka, obviously not Kafka the product itself, but another product that's similar enough that you can kind of get your feet wet and start thinking about dealing with streaming data.
Go ahead, Mark.
I mean, so there's 2 ways you can think of it. One is Amazon offers Kinesis, which is a very similar product, and they also actually offered managed Kafka. The last time I checked managed Kafka, but this is like a year ago, managed Kafka and Amazon did not have a schema registry. So that's, to me, is a big minus, because then you can't do all the fun stuff we're saying about Avro. But I don't know if that's still true. You might know a little more. But those two would be that's where I got my start in learning how to do streaming.
Yeah, and then like, you know, one of our competitors is the Confluent Cloud. You could spin that up, it'd have everything, you'd try it that way. Kafka's not hard just to set up. You download some Docker stuff and you can have a cluster running in minutes. You just, you know, spin up a little cluster on your laptop.
Yep, so one of the packages that I had worked on that we use for Kafka is, have anybody bought tickets like where you had to wait in line in the queue? You know, like there's a queue and yeah. So I worked on the team that figured out how many people should come out of the queue at any given time, right?
Cool.
Which is a huge pain in the ass. It's a whole long story. But that was all done using local Kafka, right? So I created local Kafka, I recorded on sales, and I sent messages to myself. Like you can just replay the messages back. Like you make a local producer, you replay the messages back, you have a local cluster, you have, you know, you set your partitions up as they should be, and then you have your own consumer, and then you see how the consumer behaves. And you can script it all, right? It can all be running in Docker containers. So you just fire up all your different Docker containers using your favorite Docker manager, and then have a behavior that you expect to see of the messages. And then you can script all of that so that you can then have an integration test for your Kafka system. And that all requires local stuff. That doesn't require having a dedicated ops person or anything like that.
Also, just on the idea, because my company, at least parts of our team, are really small, or at times. But what we did, for example, when we were first, we were migrating one of our old systems to Kafka to start using Kafka. So what we did is we made it so we made it so it was side by side, because we needed to compare the two. So if you have the bandwidth, and so that way you can test out Kafka without allowing it to be critical path, as long as you're careful with your code. So that's how we discovered all these problems. Like I was like, 64 partitions will make us lose hours of time. That's not okay, you know, stuff like that. So when you do the two side by side, you can kind of have someone who doesn't need to be like, oh, I'm on point on this immediately because this is production critical all the time. So if you use it as a new thing you're watching so that you can tune, assuming you have the resources to be allowed to do this, of course, so you can like tune it over time, figure out what works for your use case, rather than trying to jump all the way in all at once. You just have to be careful, of course, in code to make sure it won't take out your project when you mess up your Kafka stack. But, you know, I'm going to assume that gets coded right.
Just really quickly, officially we are out of time. Well, there's 30 minutes between now and the next presentation, so you guys are welcome to sit and ask any questions, but we should at least give them a round of applause at our specified time.
We can keep going. I'm happy to talk about Kafka all day, and I actually do like half day, full day training workshops in Kafka, so if you want to learn it, I'm happy to provide free education on that as well. It's open to the public. Not sure when the next one is, but I usually do it like once every couple months in different places. Hopefully online. It'd be good to do it online, I think.
Yeah, and the other thing I would say, again, please ask questions, but Tess Gadwa is going to be giving a talk on really cool visualization stuff.
Nice.
In 30 minutes. So hopefully everybody will be here for that too, because I just saw the slides. They're pretty cool.
Do you have a question? Okay.
Wait, well, I didn't mean to cut everything short, but I did want to make sure that you guys were cognizant of things.
I'm not, these guys probably know, honestly, a lot more about Kafka than
I think
do.
the three of us kind of like are battle-tested Kafka nerds here, which is pretty cool.
Just to an extent, it's just one of like 20 different hats I wear, so
nice.
I'm the closest thing to a dedicated engineer we have, but I'm also a cache engineer and sysadmin and deployment, you know, you
DevOps,
places,
man.
You wear a lot of hats. So I can try and answer from like the higher level. I need to remember, high level is easier than lower. Sorry.
Lower level, yeah.
I always find that funny. Anyway, sorry. But so if you have questions, provided it isn't something that's like proprietary, I'm not allowed to speak. I don't mind answering. It can be a silly question to you, but I'm sure that at some point, one of the three of us has had to suffer through it, and if you don't know the answer, it's not a dumb question. So feel free to ask.
There we go. Come on.
So this is related to Kafka, but I have a few people that I work with. I'm not, they're kind of teaching me, so to speak. I'm more of a domain guy. So they said about NiFi.
NiFi.
NiFi. Do you know anything about Kafka NiFi comparison?
Yeah, I do have
what
one.
Can be used for?
I do have one customer. It's University of San Diego. They actually needed NiFi and Kafka from a single vendor. I don't actually know NiFi, but I do know that they can actually work together. I don't know, Mark, if you.
It's the first time hearing those two syllables together. So, yeah.
Apache.
I didn't know that was a thing.
Pretty new, I guess.
Well, if it's pretty new, then by this time next year, I'll have 3 talks submitted for the data track for what NiFi and using it.
It's pretty old, actually.
Yeah.
It's one of the major products from a company like, Apache, of course, but...
came from the NSA.
Right. So this...
Yeah, it came from there.
Yeah, so this Attunity from East Coast, an Israeli company, and there's another one in San Jose, I'm forgetting, who do mastering CDC, change data capture. So they are heavily using NiFi to have NiFi has inbuilt connectors as well to port data from one place to another, like Solar, Kafka, Accumulo. You name it. It's a pretty nifty thing. And it can distribute the load, and it's got a nice graphical unit, and it can work in a cluster environment or a single node environment, and it's pretty cool actually.
What is NiFi generally used for?
Moving data from one place to another or ingesting data.
Sounds like Kafka.
Yeah. But it may have connected to Kafka. I haven't seen that, but I've seen connectors for Postgres, Solar, Cumulo. You name it, it has the connector, I think.
Yeah. I do know that San Diego is using the two things in parallel, and they were looking for a vendor to do both, so... Yeah.
If they're connecting to Solar, then they're definitely old. So.
Yeah, it might be a migration. NiFi is probably like an older version of Kafka. And then there'll be something newer than Kafka, which we'll all be giving talks on. Not sure what that is yet.
It has a data provenance a module of it, which is pretty cool, the way how it's generated, and the whole flow is graphical. That's the beauty of it.
Kafka doesn't have it.
Of what?
It's a data provenance.
The data flow and data provenance is a dedicated module in NiFi. Not the way NiFi is totally unique in a different way. It's like a flow chart. So every entity in the flow chart is a process by itself, and that is the connector to your data source or data target.
Interesting.
Making me wonder if Kafka was just sort of a reinvention of NiFi, because when you build out your Kafka clusters, you start talking about topologies, and like this is the topology, and you have a graph, and you just sort of have things moving around through it, and it sounds extremely similar. There are GUI tools for Kafka, but I generally find that maybe it's just because I'm old, but I like the CLI stuff.
CLI is the way you should.
I'll give you a very simple example of NiFi usage. So you have a folder in which data is being generated or coming in XML or JSON, module, whatever. It automatically picks up that data, and then you say target wherever you want it to go in Solar or Accumulo or Postgres or MySQL. As and when the data arrives, it moves the data and checks for duplicates and other things, all kinds of checks and balances. And your logic and your iteration logic also can be inbuilt into it. So you can make the process as complex or as simple as possible.
So is NiFi, Kafka is like, at its core, it's a distributed commit log. So it's all about appending bytes to a file. Is NiFi like file optimized, or is it a similar architecture?
It depends upon other products.
Oh, okay. So it has no storage strategy then?
Yeah, so basically wherever you want.
Sounds like a good trading use case, actually.
Actually, there is a flow, data flow of NiFi available online, which I'm trying to check on, which captures your trading data and ticker symbols and everything.
No, it can do that, but probably not live.
I haven't checked that, yeah. In fact, I'm really surprised that we don't have a single Apache NiFi session this year.
Yeah.
That's really surprising to me.
Did we have them in previous years?
It's documentation on Kafka. There you go.
We have seen each other many times, yeah.
Send me an email.
No, absolutely.
Yeah, send me an email. I'll tell you when my event will be.
Well,
Yeah.
Datacom? Yeah. Well, if you want to submit a talk for next year, we can have that conversation.
I mean, I'm interested in learning about NiFi. It sounds actually kind of useful.
Yeah.
It's very configuration driven too.
That's the same as Kafka. Sounds like exactly the same.
That's why I asked the question. I didn't want to.
No, it's,
See, any flow can
We're-
have
we're
a
in
jar
the
file
in-between
in it.
time.
And that process, so you can call any program, any process within the process.
Interesting.
Yeah.
very cool.
Boy, this next thing that's coming here is really,
Is what?
it's 3D rendering.
3D rendering is pretty damn cool. I think I might stick around and watch that one. I don't know about you guys.
I'd never heard of that library, 3JS.
3JS?
Yeah.
3JS is pretty cool. You can render 3. Have you heard of WebAssembly?
Yeah.
Have you ever heard of Quake 3? Yeah, you can put Quake 3 in a web browser now using WebAssembly. It's pretty cool. Yeah. Yeah, 3JS is cool. Well, you can compile anything in WebAssembly. It's just a matter of, what's it going to do. Because you can compile any, library. There's a vendor showing his Quake 3 library. I thought it was pretty cool. Or maybe it was an open source guy. It was still pretty cool, though. It was Gentoo. Yeah, it was Gentoo. Yeah, Gentoo guys. They had a little Quake 3 demo running.
Yeah, they had a booth here. Yeah, no,
Yeah.
A lot of these distributions that, just seem to have one time proliferated all at once, and somehow some have risen and dominated.
I mean, Ubuntu is the one that I stuck with for 10 years, and someone made me do Gentoo for a couple of months. Oh yeah, we'll compile the operating system on your laptop, and they updated it, and it broke. But Ubuntu always kind of worked, and it seems to be a popular server thing too. So that's kind of what I'm used to. I stick to that. Although now my operating system's Mac because I'm, lazy.
it's the most maintained version of FreeBSD around.
Gentoo?
No, Mac.
Really?
It's
Nice.
It's FreeBSD. It's
Nice.
FreeBSD. So, well, yeah, no, the next talk I'm looking forward to because music linkages like that and music visualization is I did a lot of the recommendation stuff at Ticketmaster, so this is a topic that's near and dear to my heart. So, what's that? So if you've ever gotten an email list from us that says bands in your area that you might want to see, stuff like that.
Oh, that's pretty cool.
The personalized recommendation engine from us. That's. Yeah, no, it's funny. We actually did some surveys that showed that most people under the age of 35 are totally okay with Ticketmaster, and people over the age of 35 hate us. I still remember that.
It's just, I don't know. I mean, there's Disney Hall. I mean, if you're a classical music person, I don't think there's anything on Ticketmaster.
That is not true.
And maybe there is. I'm just saying. If you use it, maybe it's behind the scenes or something.
We'll ticket opera. We ticket everything. Yeah. At the Dorothy Chandler Pavilion. Yeah.
See, that's the thing. If you go and do on call or something, you have no idea where it's going.
Yeah, that's true. I mean, what? You don't immediately purchase your shows based off of who's doing the ticketing? What kind of craziness is that?
The most popular stuff, Ticketmaster is the face of buying materials, right?
Yeah. Yes, indeed. Well, cool. So we are in the waiting period.
All right.
15 minutes.
Wow, this was a good talk. It was
Yeah,
really
thank you, Zeke.
great, honestly, great audience. I'm based out of Redwood City. I have family in LA, so I'll probably be here all week.
Is that where, that's where Instaclustr?
We're headquartered in Redwood City, yeah, the Bay Area. Pretty much my entire family's in, Sherman Oaks, Whittier, Brea.
I see. Now I'm learning that qualifies as local. If I said, are you local, you can say yes.
I can say yes.
How would Sherman Oaks not be local?
Well, I'm from New York.
I'm born and raised from New York.
20, 30 miles, right?
12.
Seems like a long way.
Well, that's just because traffic in LA is hard.
Right.
I think the other one's about halfway, but we only have one talk left, so I don't know.
Okay, it's live. Okay. Testing. It's not that, it's just more that my hair is going to get in the way, I think. Unless I pulled it back in a ponytail, like.
You do you. So that, like I said, when they ask questions,
Mhm.
please just repeat the question.
Absolutely. Try to remember that. Tell me, is this volume right? Am I holding it too close or?
No, that's actually a little bit jumped.
Okay, all right, I'll hold it even closer then. Okay. Okay.
So that's about how close she is right now.
All right. Yeah, just so long as I'm not going to blast anyone. Don't be too loud. Mhm.
So yeah,
Okay, thanks. Yeah, just let me know if you can't hear me or other. Yeah, I'm not a hardware person. I'll say that a million times.
Yeah, I think you're probably the quietest person we've had on track, so
Mhm.
just keep it close. The volume's been adjusted for loudspeakers like myself.
Uh-huh.
So keep it updates.
Right, right.
You gotta remember about long spaghetti.
Do my best.
Show open, yeah, boom, straight to the peak of traffic. So you can't scale when your traffic goes from 10 TPS to 10K, 15K TPS in 20 seconds. Yeah, so I mean, it's like you have to be ready for that. There's no, your understanding is only.
Okay, I'll probably put this down at some point.
There's no.
The real suspense is, will this trackpad work? This is a MacBook Pro from 2012. If you have one that's compatible with a Mac, I will take one just in case. No, it completely works. I just noticed it was behaving a little bit oddly earlier in the day, and then I had to reboot it. On this side. Got two. I have two. Yeah.
Okay, I will go up and get one of our mice.
Okay.
It's not a Mac mouse, but
Yeah, usually they're pretty interchangeable. Yeah. If they're USB mouse. Yeah, there's one on the other side. Yeah, okay. Thank you. Yeah. Thank you. Hi. So thank you all for being here. I know this is kind of an unusual year for SCaLE, and especially for anybody who traveled. Just thanks for showing up. Some other things to know before I dive in. I was told originally upon submitting this talk that people had trouble really understanding what it was about. So I decided to take a step back from the technical part and add some explanation as to why this technology exists and is being developed. So we may do more or less of a deep dive, but I really wanted to start with the reasons for me, some of what my passions are. And parametric geometry is the particular discipline that we'll be discussing. But content discovery, for me, was what drew me into this field and got me energized. And this is a tool set that can be used for a lot of different things. You can use it for market research, you can use it for trading, you can use it for epidemiology. We'll talk more about that. For me, what was most interesting was really discovery. And so without further ado, I'm actually going to start by talking about a book. This is a book called Decrypting Rita by Margaret Trouth. It's a comic. It's It's a very innovative comic because it's all digital. All of the artwork was produced digitally. It's all vector art. Very interesting story. It's about a woman whose boyfriend traps her in several different parallel realities. Very unusual storytelling. It's like the Ulysses of comics. It's a really interesting, complex read. I'm going to guarantee, I would bet if I could think of something good to bet, that nobody in this room has heard of it. I stumbled upon it in the author's hometown, which is Seattle. And then when I was in Portland, where I lived, the actual comic book shop where I tried to look for the next volume, this is only volume 1 out of 3, they'd never heard of it. And if you stump the comic book guy, you know it's probably pretty obscure. And so my question really is, what's missing? This is an interesting topic. It's unusual. It deals with queer themes. Why didn't more word get out? Why is it only available on a small press? Why did it never get picked up by an influencer or have social media kind of propagate that story? This is one example, but there are so many examples if you follow the world of independent media, of music, film, books, all of these voices that just get overlooked. A lot of my friends are artists, and I'm blown away by their talent. But it's really, really difficult to advance to that next level unless somebody famous picks you up and popularizes what you're doing, or unless you pay a whole lot of money to marketers and publicists and advertisers. And that's the impetus for the title of this talk, which is Discovery Without Marketing. That is the pull behind the problem that I'm trying to solve, which is basically how do we widen up this playing field again? This may be only a Generation X thing. I'm very much Gen X. We love to put obscure songs on mixtapes. We love to just sort of wow our friends with references. But even aside from that, my feeling is that knowledge is getting lost and missed and passed over. And it's not just me. I've gone on my little soapbox for the first few minutes. I'm now going to actually share a very brief conversation I had on a social network with a senior manager at Amazon, and we talked about content discovery. And he confirmed his exact words, that's the biggest issue we're all tackling. So the most major corporations, the Amazons, the Googles, the Spotify, they're grappling with the exact same problem, which is there's this fire hose of information and no way to get it to people who might actually enjoy it or like it or benefit from it. 4 million songs on Spotify have never even been played once. If you happen to be the creator of one of those 4 million songs, that kind of sucks for you, but I think it sucks more if you're the listener, because people have very different tastes. We're all different people and different beings, and what we enjoy unfortunately gets compressed. So, to be very clear, this was not a protected conversation. I talked to the guy before, and we just talked in very general terms. Amazon's solution, or so I'm told, is pretty much predictive algorithms. They're doing some things around the UX, but predictive algorithms basically considered the way to go. The problem being, you have all of this data out there, and you're narrowing the stream to maybe 3 or 4 or 5 suggestions that pop up on a page at any one given time. You're trying to drink an ocean of knowledge with a straw. And it's limiting. And if they get something wrong, it can be very frustrating. I listen to YouTube almost every day at work, and I'm always just boggled that the same songs come up again and again. I do everything I can to just seed the mix with obscure music, but somehow it always comes back to early 80s new wave. I don't know why, it just does. Our goal is really to take that fire hose and turn it into something more like a fountain, where there is order and pattern and there is a predictive element, but there's simply more choice and more access to a wider range of results set. And we'll drill down more into what this means as we go further. AI plus UX. It's funny, there was a talk about this here at SCaLE yesterday, AI and design. I just read an article on the subject a week ago. It's starting to be a hot topic, I think. You know, how can AI improve design? How can it help designers innovate? Mostly what I've been seeing are tools for, say, producing better textures, optimizing CSS, just creating better aesthetics, making designers' jobs easier. These are very worthwhile goals. What happens when you combine AI plus user experience and design with parametric geometry is something else entirely. And this is where we go back to the deep dive just a little bit. What is parametric geometry? Parametric geometry is a way to draw graphics using equations, not pixels. So basically three-dimensional vector artwork. And there are any number of tools and languages you can use for parametric 3D designs. 3.js is what I built these models based on. It's a JavaScript 3D animation library. It was released in 2010. And what's neat about it is it's fully web-based. You can use it on a phone. You can use it on any browser. You don't need to download additional software. It makes a 3D environment just immediately accessible in any browser environment. Here's a bit of an example of what it might look like. And you can see there are controls. Typically, it's very easy to manipulate surfaces, shapes. If you're interested in any of the stuff, I really urge you to check out the website 3js.org. It's updated all the time, and there are so many just great examples of cool things that people are doing. And those can be anything from modeling and rendering to artwork, all the way to games. And so it's a technology that's been around for a number of years. It's mature. I think it's maybe a little bit underutilized and overlooked, but it's pretty well developed and pretty well built out. I'm going to show you the first parametric geometry project that I worked on in depth, and it's actually a trading analytics application. So what this does, it's 3D, and every line on this graph represents a different altcoin. There are 2,100 lines on the graph. The ones in the inmost circle are your Ethereum, your Bitcoin, your Litecoin, the ones that are best known and have the highest coin price. The ones on the far edge are essentially penny stocks. So coins that have a much lower price and are more in the emerging range. And again, apologies, very simple interface. This isn't something that's going to win any design awards. I designed it to be functional for me. The lines represent growth trends. So a coin with a pink line, that's a 20% growth trend. A yellow line represents a 5% growth trend. you can click around, you can adjust, filter out anything that's less than 1 million in volume. You can look at price changes over an hour, over a day, over 7 days. And where this is different than most charts that you find in most trading tools is you also have the opportunity as you click through and as you look at the different highlighted coin lines on the chart, you can click and you can actually go directly to the coin and learn a lot more information and see, well, how is Bitcoin gold doing? It doesn't seem to be doing very much lately, but what does the trend look like for the last week? That's kind of interesting. Maybe it's a buying opportunity. Maybe it's not. Essentially, this is a way to just get a whole lot of trend-based information in one place. And you could apply it really to anything. It's just calculus, addition, subtraction. It's a spreadsheet on steroids. And of course, I don't know how many times all of you have heard the word coronavirus in the last week. I think in terms of epidemiology, and I think what if you used a chart like this to be able to update the number of cases in different municipalities in real time? What if you could see on this chart 3,000 cities and not just see the total number of cases, but see where rates were rising highest? Because it means something very different when you've got a high growth rate, from 1 to 2 cases, that's a 100% increase, versus if you're in the middle of that chart versus close to the center. So this is sort of the easiest and the original way to use what I've been calling Lotus Petal Architecture. And that's basically just to analyze trends data. You can apply other kinds of filters. I'll show a few examples of what that looks like. But essentially, it's just a visual way to get a really large at-a-glance sample and then be able to drill down very quickly. Go ahead. Each one of these lines on the chart is actually a currency. So, yes. So and the significance of, I have to do a better demo. I will at some point. The significance of the ranking of the petals is also important. The topmost link will have the highest value, and then as you go through the petal, the values descend. It's really designed to show information where the order of the top 10 is maybe not that important, whether something is 1 or 2 or 4, but to be able to show that in the context of the top 20 and 40 and 50 and just rank a lot of information numerically. So once you're familiar with this type of chart, you know that something that's a short line in an inner petal is going to be very different from something that's at the top of the petal versus something that's a long line. The circle, are you talking about the ring shape? Yeah. Underlying? It's just part of the geometry. In terms of what they represent, the innermost circle is typically going to be the highest value, and that could be defined in different ways, in price, in number of hits. If there is a middle circle and there is an always, it will be in between. And if there is an outer circle, then that will be the lowest value, so the outliers or the emerging data. And one of the interesting things about this structure is you can very easily make it fractal. And in theory, represent a limitless amount of data with a shape very much like this. You have your inner ring defined, you have your outer ring defined, and then the middle would be something that you would just drill into and dynamically update. One of the great potential uses of this tool set is that it integrates really well with Node. So creating real-time charts that update automatically, once you have that framework in place, there's nothing to it. Go ahead. Great question. And I'm tempted to actually take you further into the presentation. I'd urge you to look around at the lotus.fm splash page, because there all of the links will be active. Here it's just a subset, because it was just distracting to have all of them be active. I only wanted to focus on the coins that were showing growth. But your question, can you repeat your question? Yeah. Yeah, chart lines. Yeah, the basic building lines would be chart lines within a petal. The number of petals within a ring, that's a user-defined variable. Some variables work better than others. It's important, obviously, that you choose a symmetrical number. And so, in terms of how you wanted to structure it, you really want to structure just for clarity. In theory, you could put thousands of lines up on the screen. This one is 2100. In theory, you can go up to 3000. I wouldn't necessarily push it to the very edge of that. But it's basically just assigning data in a way that you know highest values along the top, next highest level values, one rung less in height. Next highest, so it would go essentially 1, 2, 3, then it would go 4, 5, 6, 7, and then on to 8, 9, and then on to your 10, your 11. Again, it's hard to see on this example, but hopefully this is making some kind of sense. It's just a way to count an ordered list from top to bottom. And what's cool about it is that it's a much more efficient way to display data than your standard bar chart or your standard spreadsheet or list view. Just to give you an example, this is 2,100 coins in theory. They're not all lit up. They could be if that was wanted. And now we're going to go and we're going to actually just do a little experiment to see how long it takes to scroll through the same list of cryptocurrencies and on CoinMarketCap, which is where all this data comes from. I'm having to be careful with the slides right now not to reload anything because I just went over my API limit for the day. But so we're scrolling down. We get to 29. Yep. We keep scrolling. We keep scrolling. Yeah, so far, this is equivalent, we're at 54, so this is equivalent to about one of these petals in the center. That's how much is being shown. And it's abstracted, but it's not all that abstracted. You can use JavaScript to just immediately mouse over and preview the results. You can navigate very easily to links. It's an interactive map, basically, a way to see the big picture. Totally. and we're going, and we're going. Still going, still going, still going. I'm honestly scrolling as fast as I can, and we're now at 200, and it's going to ask me to load more. Yeah, so imagine you're a day trader, and you're trying to just sort of make the next big score with cryptocurrency, and you're just trying to look for that one thing which is kind of mid-cap and rising and showing growth. It's really hard to pick the needle out of a haystack with a format like this. The goal is basically just to sort of find the information you want and be able to flag it almost instantaneously. So that's what appealed to me. Yes. Yeah, right now this is only showing ups because I was actually only interested in what was trending up, but you could very easily add in red lines. Yeah, you could zero in. In some ways, a graph like this is more useful if you're only looking at, say, the top 400 only. So you might want to look only at mid cap or low cap or high cap, but all these parameters are very easily customizable. And I would say for anyone, as far as trying this at home, this link is actually available with the talk, and it is a public link. But again, because I'm using this under a personal license, if you get there and it's broken, I would just say don't blame me. It's something I would love to have the means to make available to more people if there's demand or interest. We'll talk about that in a bit because the TLDR design inventions are very hard to protect with open source, and we're trying to do it right, which means lawyers. So we'll get there, but thanks for asking. So some more background just on what are geometric links. This is a term. It's not an image map. It's basically just an object that's wrapped around another object. One set of functions is used to actually draw out the geometric shape, and then another set of functions. It's all just JavaScript, very simple client-side stuff is used to assign different lines of value and make them dynamic and clickable. So I'd love to be able to go through some of that code. Hopefully that will be possible in the very near future. And you can obviously make a 3D parametric geometry structure and map it to anything as part of any application. What's great about 3.js, because it's already written for the web, is it's just very well designed to use with links. It just really lends itself to that. So all of us remember image maps. Maybe your first coding project, like you got very excited and you put all these circles and squares on a graphic. Not a lot has really been done with navigation conventions since then. They're text links, they're buttons on web pages, ways to swipe or to hover. But geometric links, my feeling is that they have a lot of potential just as a way to be able to access a vast amount of data comprehensively and quickly. So that leads me to, people are occasionally asking, what is Lotus Petal architecture? What does any of this mean? And I was like, I really have to show you. It's very tough to explain in words unless you've got a very good visual imagination. But basically, it's just a front end for big data. That's what it is. It's really good for revealing growth trends, like we talked about, be they stocks, be they epidemiology. It's also very well suited for machine learning insights. So, we're not limited to pure calculus here. Something goes up 10% or down 10%. You can use it just with, hello folks, make yourselves at home, with any kind of output from any kind of training data. And there are a lot of ways in which this tool can be used. There are a lot of ways to see the story of the data. It's very good for anything, be it real estate, HR, online dating, where you're just looking and making a quick thumbnail assessment within about half a second. Am I interested enough to find out more? Am I not? That's the time frame that it's very well suited for. I like applications in the area of media and content discovery, but that's pretty much because, well, several reasons, but one of the big ones is just I'm an artist and I'm really interested in where art and code overlap. So so go on. Uh-huh. Could you repeat that? I didn't hear. Could I show or state a realistic example as it relates to this? Yeah, absolutely. This isn't going to be a very exciting or sexy example, but it's one that occurred to me. Let's say you work at a bank, and the bank has a fraud detection department, and you're one of the managers who's actually assigned to fraud, and to investigating fraud, and deciding what cases are going to be handled by the automated system, and what cases are going to require further resources and require manual intervention. And you probably have thousands of different notifications cross your desk every single day. And you have to have some way of prioritizing them. But if you're using a system where it's just based on what comes in first, or just a few indicators, you're going to miss things. So this becomes a way that you can just, for workflow, very easily scan through a large amount of tasks and see what's the most urgent. And just look from the point of view of several different parameters and several different filters. And again, see what's the most urgent. Is that answering your question? You'd requested a real world example. And again, it helps if you see it in action. So, yeah, I talk a lot about the lotus. The lotus flower, it's a very good shape, but you can build parametric geometry to look like anything. This is an artichoke, for an example. Succulents are another really great natural organic shape that can be adapted. A starburst or ray, again, forms that have symmetry are very well suited to parametric designs and visualization. If you're creating a new model, I would really urge you not to overload the types of data or the whistles and bells. You want it just to be easy to read and to make sense, and for people to sort of develop more subtleties as they spend more time with it. Just even a simple grid can be a great framework just for navigating. Actually, probably my next task, how many of you have read William Gibson's Neuromancer at some point? Great, yeah, I see some hands, so at least 3, excellent. I would like to actually make a clickable grid that just resembles what he writes about in his book. That's on my to-do list for this spring, because I think it would be cool. And it's like Bowl of Lucky Charms. You run into some copyright issues, but you really could make parametric geometry that was just like a cereal bowl. I think it makes a lot more sense to think carefully about your use case. If this set of tools becomes more widely used, certain standards are going to emerge. I did the first version of this talk about almost a year ago with a 2600 group, and just some of the examples we threw around: surfing the web again, doing an animated news ticker where the volume and the height would oscillate based on the volume of news and the amount of traffic being generated. I really think it's important to do some work in this area around climate change and better visualizations that help people understand that these problems aren't just about borders on a map, but really looking at trends in different parts of the world and finding commonalities. So, you could have a community in Texas and a community in India which are experiencing very similar phenomenon, but they don't know it. They have no way to relate the drought or the flooding that they're experiencing, or sort of know what other solutions may have worked in other communities. So that's an area that I'd love to see more work done in. And I'll also say, even though most of the examples I've talked about are 3D, because number one, it looks cool, it's great for VR, and you can actually show a lot more data. Parametric geometry doesn't have to be 3D. Something very simple you could do is a search engine, which is color-coded. And suddenly, instead of having 10 results show on your search screen, you simply mouse around. You have maybe an area that's for classifieds, an area that's for news, an area for social, and an area just for organic search results. More popular results appear in the middle of the graph. Less highly ranked results appear near the end. And suddenly, at a glance, you can search on a single topic, maybe cars, maybe a particular model or make of car, and very efficiently and meaningfully browse through 1,000 different results instead of 10. So for people who like to have that greater choice, who like having access to more information, not everybody does, some people do, this is a good tool for you. And now I'm going to show you just a little bit of another implementation which is slightly more advanced, but still very much a work in progress. One thing I've got to say, so this is an interactive chart showing the top 400 music videos of all time from Portland, Oregon. And as most of you know, South by Southwest was canceled this year. It's a little harder to find out what the really good trending music is, what you should check out. If you're an A&R scout, whoever you are, it's hard to be in the loop. So maybe check out something like this. You've got the very well-known bands in the centers. You've got your Everclear, yes, Everclear. You've got your Shins. You've got your Quarter Flash, Dandy Warhols, and a lot of bands basically that you'll recognize. And again, this is only 400 links. It's actually a little fewer because I haven't filled out all the spots yet. But you can still see the difference as you go from the inner to the outer pedal. And you get out here, and you click on these links, and suddenly it's music that you've never heard of. And I would love to actually play some of these songs for you, because a lot of them are just good and interesting. But since this is being streamed over the internet, that's not possible. If you light up all of the genres, this is what it looks like. If you choose, say, just hip-hop, you can see where hip-hop is represented in Portland. Lots around the periphery, around the outer pedals, many fewer in the inner pedals. You don't have to click on a link to actually see what it is. You can just mouse over it. So this, to me, it's closer to the experience of actually being in a record store, just thumbing through a lot of records or seeing them in front of you versus the experience of being on an online, either an online shopping experience or music experience where you're just clicking, clicking, clicking and getting these neat little grids. You can see more in less time. Where did I get what? The data? Oh, it's all YouTube. And that we kind of want to move away from that because one lesson I've learned is that any proprietary API can go away unexpectedly with very little notice. We thought it made sense to start with YouTube just because we could get access to a lot more artists and materials, but we're working on putting together our own song list. We've got about 800 songs now, and the next iteration of this will ideally be based out of Creative Commons licensed music and include several million songs. So that's where we're aiming to get. Does the geometry reflect attributes of the videos like popularity, was your question. And the answer is yes, exactly. That's what it is. Again, these top links in the center, those are the all-time 8 most popular songs. This is number 1, the Shins' Simple Song. That's the number 1 all-time video for Portland. And you can go through the list. Number 3 is Quarter Flash. So we're not looking at a lot of traits. We could add in something like growth trends, definitely the same way that we did for the cryptocurrency chart. But right now, we're primarily just looking at overall popularity and genre. And then there's a pink overlay on the inner ring. Partly that's a matter of aesthetics, and it's also just to indicate, again, that there's a difference on the values and that they're a little more popular. So, your question in the back? It's all done based on, they're all ordered based on the number of views. So it changes dynamically over time. Every time this page loads, it's updated through a series of API calls to YouTube, and based on that information, the songs are assigned their slots. Okay. You could do them either way. At the moment, a lot is hard-coded because it's just easier, and you get fewer unexpected results. You could definitely build a model where the number of petals was elastic based on the input of data. You'd still probably want to have a maximum and a minimum value shown. Right now, the number of petals is hard-coded for each visualization, yes. And thank you for asking that question. Yeah. It's really, really difficult. Is the answer. Right now, we have a provisional patent filed that was filed early last summer. Before that expires, we need to make some licensing decisions. It's a big decision. I don't want to make it alone. A number of other people have been part of this project, and we also want to give people who may be interested in being future stakeholders an opportunity to comment. The real challenge with any type of UX innovation, and there haven't been a lot, honestly, in the last few years. You know, you've got your mouse, you've got your browser window. There haven't been too many major changes. Is that they are very easy for a larger organization to copy, to change slightly, and then to apply what's called a design patent, which is different than a utility patent. Utility patent is back-end, that's the code, that's the 1,500 lines of JavaScript, not that exciting. I'm sure some of you in this room could probably replicate it all in a day or three. But the innovation itself, the idea of just a different way to use code is more vulnerable, because while you can create a precedent through what's called prior art, and that's part of why I was showing some other examples of what this might be, is, in all honesty, to establish prior art. If somebody thinks of a new one, and they have the muscle and the dominance in the market, they can then go ahead and sort of really push for that to become the standard. And that's unfortunate, because you end up potentially with a lot of slots being hogged and just redundancy. So I don't. In a perfect world, it would be possible to just open source all of this and have it all remain in the commons. I've been talking to great people at the Open Invention Network about how to do that. Basically, we need to put in a really strong defensive publication. It's looking like that's going to require additional legal resources. So that's, I mean, good question, but there's not an easy answer. Yep. Yeah. Well, we have some talk and some time, and that wasn't a public talk. So for instance, this thing, which is now upside down, to refresh it, is this was launched on Veterans Day of November 2019. So we have, and likewise, the first implementation, the coin implementation, that was just for my own personal use, and that was never made public. So we've been trying to keep an eye on the code, but really just our goal is, number one, to get this into use, because we think it has a lot of value. Number two, to do so in a way that benefits the commons and is accessible. And I would like to be able to continue working on this. I have a day job, but for me, this is very fascinating and interesting stuff. But go on. Yeah, it's chart. It's an interactive chart. Yeah. I mean, and it may be that somebody else has done something similar based on my research. I haven't seen it. You know, if people can send me other examples, it would save a lot of headache and some resources and time. But yeah, it's this approach to 3D visualization, which it's essentially building something that is interactive. And at the same time having those interactive geometric links represent actual data. Yeah, they're It's certainly relevant, because if you were to say build within a compiled platform, and as a desktop standalone app, you wouldn't be able to do all of the same things that you can do. I'm a little bit familiar with it, yeah. It seems like they'd probably play well together. But yeah, the fact that this is a set of technologies for the web, that's one of the reasons I'm so passionate that I believe it should be open. It lends itself well to any set of protocols where there's interlocking data and where you're able to just preview and navigate quickly and cleanly to other sites. That may not be the direction in which the consumer or the business web and world of technology is going. We're seeing many more walled gardens. Could you integrate this into a spreadsheet program? Yeah, absolutely. I don't think that would be a bad thing, but to me, what really makes this special is the fact that all of this data, you don't just see it in front of you, it can take you places. Yeah. At this point, it's is really, it's a whole other talk. We spent a lot of time last summer working on an Ethereum blockchain model for how to fund an open source project without an ICO. That's really, really difficult. ICOs were a great way to fund open source up until the SEC clamped down. That actually happened to me. I ran a very small boutique boutique ICO just as that door was closing. In answer to your question, and I'll get you, can you rephrase it so I can say it in the mic this time? Well, you're saying it sounds like our intellectual property strategy is more defensive than offensive. And I would say, honestly, at this point, all options are open. What we want to find is a way that this technology can develop to its fullest. That probably does require some capital. The way that we think is best to pursue this, ideally, is to do what we call smart crowdfunding. And that is basically a way in which you tie the license to a specific funding goal. If the goal is reached, then the code is licensed. If the goal is not reached, then the code is not licensed. But code is law. You can't have any sort of last minute back alley negotiations. You can't have Microsoft suddenly call me up and be like, oh, we'll give you $1 million for this. I mean, that would be nice if it happened. For where we are right now, I think that we are pretty much focused on just tying this up in a way that not only do we and others have the freedom to innovate, but somebody else can't come along and close off major areas of thought after us. That really is our goal. I think the big challenge, if we go for, say, a copyleft solution and go sort of the most virtuous and idealistic path, is who would then be prosecuting any kind of breach? Who would have the resources, or who would pick up that banner? So these are just, some issues to contemplate. I'm going to move along now since we're almost at the end of time. Some next steps for this project. The big one is developing a mobile UX. I have some thoughts about that. Hint, hint, it's not just zoom and pan. Equally important and very closely linked, keyboard and assistive support. Right now, this is not a good platform if you have vision disabilities or if you don't like to use a mouse that much. In the next iteration, it will be the opposite. It will make it much easier to tab and toggle through your work, and that's where some of the workflow management applications that we were talking about earlier also come right back in. My former administrative assistant has a vision disability. She's a good friend, so she'll be the live tester on that part. Just as part of all of the next steps, we've got a lot of code refactoring in front of us. If any of you try this out on your own on Firefox, I should warn you, it's a CPU hog. You'll probably see spikes of above 50%. That's a known issue. It will be fixed. One of the biggest challenges is making time for continuous iterations of usability testing in particular. In most cases, you don't have the designer and the person who's developing the code in the same role, and there's a reason for that. It takes a long time. It's very humbling to put something that you worked on in front of other people and watch them click around and figure out which parts they get, which parts they don't get. What makes up for it is when they light up and when they see the value in what you're doing. But we're really committed to not just doing something that looks cool, but something that's really usable and really intuitive and sets a new standard for design. And then this is the fun part. So you've seen the current Lotus chart. This is all based on quantitative data. It's all based on ranking. You know, it's like a top 40. It's like, you know, one of the old countdown charts in its own way. And all of these links only plays a single song. So that's really a limitation at this point. And there are ways we could get around that, but then we would be going very deep into YouTube land, and we sort of want to do our own thing. What does our own thing look like? It's going to be cool. It's going to have a different interface than the Lotus, although containing some similar elements. And it's going to be a predictive AI system, which incorporates training data from about 600 plus microgenres of music. So our goal, if you can get to enough different categorizations, say your acid jazz versus your free jazz versus your Dixieland jazz, and train a machine to recognize those categorizations, what that means in theory is that you can work with a smaller set of data to put together an intelligent playlist that's customized for the user. You don't need many millions of songs. You probably still need thousands, but you can work with a set of data that's workable and is available within the commons. So we're really excited about that potential. One of the things people often struggle with when they choose a CC license is, you know, how is this music going to get seen or heard or found? We believe that our solution, which is real and practical, I'm working with 2 other coders in the Portland area, as well as 2 who are remote. It's something that's very implementable and can change that balance. So that's where we're hoping to go. Other fun use cases, we've talked about VR and AR. I'd love to see a hologram of the Lotus pedal. Just think that would be fun. There is a lot of opportunity for AI to actually design and generate this type of discovery module down the line. And there's a lot of opportunity to build GUIs just to make it easier to configure the system. So again, coming closer to just being an extensible spreadsheet. So we think that's cool. And in terms of where we go from here, I would really like to say, if you're at all interested in this, connect with me on GitHub, on Twitter, wherever is preferred. My personal blog is Art Meets Code, and we have a lot of very important milestones and decisions to make coming up in the next, say about the next 12 weeks. So if you'd like to be a part of that conversation and that discussion, we really invite you in. The way I've set up the public repo, for example, it isn't actually a public repo. Right now, it is a README file, a roadmap for a very ambitious project we could take on. And it is also a way to vote on the license. I just created 2 issues, one for permissive license, one for copyleft. And if you want to be involved, join the repo, leave a vote, and leave comments, or suggest another license. It's all good. I like to think of myself as benevolent. I'm not much of a dictator, but if you would like to be part of this project or know people who are interested in any of these 3, front end, design, AI, or music, get us in touch. Thanks very much. Any other questions? Okay, you first.
So it's a form of visualization that you're saying you're putting out there that is more efficient or more something, right?
Yes, more efficient, saves time. You can see more data with context in less time. Yes. Well, not necessarily, because what it works really well for is identifying what's trending but still not that popular. So things that are coming up. There. It's the difference between the outer ring, which is emerging artists, the middle ring, which is just the middle in between, and the inner ring, which would be the really well-established superstars. It's certainly a function of popularity. It's just opening up the space from maybe 3 things that come up on your Twitter feed to 2,100. Did you have a question also? If you're curious about it, talk to me. There is a private repo, and I am fairly trusting in terms of who I grant access. I can't put it out in the public yet. So in answer to your question, you're saying, so for big data, the paradigm stays the same. The higher the peak, it's closer to the center, versus if it's further out, it's a lower value. And the answer is really yes and no, because parametric geometry is not just the lotus. It's what you build for yourself. And we hope that other people will take these designs and come up with more shapes and more forms and more models that haven't even yet been thought of yet. This one, it's optimized for trends analysis. It's optimized to show what's up and coming. It's optimized to show the punk rock band that maybe they only have a few hundred followers on Facebook, but they sell out at every show because they're awesome and word of mouth is spreading. That's the kind of thing it's good for. I should stress this is not just about the arts. It's also about code, and it's also about creators, and it's also about scientific literacy. We're living in an age right now where we have so many challenges in front of us. We need every perspective we can get that has value to be found and not overlooked. A great example, actually, to go back, am I allowed to keep talking? I see somebody at the door. Yeah. A great example, if an overused one, is Satoshi. And a lot of people say, well, who was the real Satoshi? Who is the real Satoshi? I think the very interesting question, and I happen to know this, is how was Satoshi discovered? And he was discovered in part by a man named Gavin Anderson, who's a friend and a colleague of mine. We both come from Western Massachusetts. And we were talking about this over lunch one time. It was just like, so how did this Bitcoin thing happen? He's just like, yeah, I read the white paper. I thought it was interesting. I got some friends of mine to start mining, and this person who was not famous or a celebrity himself was able to get word of mouth and get a critical mass of interested people to where something could take off without marketing. It took something like 6 years from Bitcoin to go from being worth less than a penny to becoming a multi-billion-dollar juggernaut. But it happened. What's that? Thanks to many things along the way, but the biggest challenge is always at the very beginning. It's that moment when there is a vector for information to spread. So I guess my question is, there are names that are discovered, like Satoshi, and there are names like Margaret Trouth, who remain kind of obscure. And apples to oranges, completely different industries. Maybe I shouldn't make that comparison, but I often find myself wondering how much is out there. Einstein was working as a clerk in the patent office when he published the theory of relativity. How many brilliant minds out there, how many in particular contributions, and I will say this because it is International Women's Day today, how many contributions from women and minorities are overlooked. As a queer female disabled founder, I have some obstacles when it comes to finding venture capital, maybe, but that doesn't really bother me. I think for me, what I'm most concerned with is getting this paradigm, which is open source, to be something that can work as a viable system for everybody, and really just allowing information to flow freely. So that's what inspired all of this. Yeah, that was my stump speech. I'm done now. Thank you. Thanks all of you.